Good afternoon, all. We are going to start today's session 2. I request Dr. S.L. Bhagat sir to introduce today's speaker.
Good noon to one and all. Today we have an eminent speaker, Sunil Patil sir. He has completed his ME and he has started his career as a process engineer from Galaxy Surfactants Limited. Then he has shifted as a lead engineer in Honeywell Industries Limited, Pune. And after that, he is continuing his career with Asia Pacific Sales Group of Aspen Tech. He was at first a senior principal business consultant, and now he is working as a director as solution consultant in Asia Pacific, Japan. I welcome Sunil Patil sir for today's session, and I think all the participants will be very fruitful to hear his presentation, as he will be sharing all his industrial experience with respect to all the softwares what are being used in the industries. Welcome, sir.
Thank you very much, sir. Thank you, and good afternoon, everyone. I hope you can hear me very well.
Yes, sir.
Okay, let me share my presentation. Just confirm once if you can see my slides.
Yes, sir.
Okay. Thank you all, and first of all, let me thank you everyone for inviting me to your Atal event. I think it's very fruitful for everyone. I have been listening that there are a lot of good sessions you already had from some eminent speakers and so university professors and doctors. And it's my pleasure today to present my experience in the industry about process simulation and optimization. And as rightly introduced, yes, my experience is precisely what he explained, but I will reintroduce myself briefly in a minute. Before that, you might know the topic which is shared with you earlier. Applications of process simulation is mainly around Aspen Plus and HYSYS in the process industry. But I did make slight change, and then I wanted to give a flavor of what is happening in the process industry with regards to automation, with regards to digital technology, and with regards to what we call the sustainability and what is now really it is called industrial AI, right? So it is more of an advancement where industry is heading now. Changes happening in the process industries, impacts of the pandemic, impacts of the crude oil changes, and so on. So you will hear a lot many things from me. So it's more like an hour and a half presentation, and of course I would like to take questions from you. Please feel to stop me, ask the questions in between or at the end, whatever you feel comfortable. There's a chat window, you can type in the questions and I'll be happy to answer as well. With that, let me start the presentation. As you can see the title, right? What I'm going to talk is about, not about the process simulation, which you all are familiar with, right? But I'm really wanted to give a flavor about what's happening in the process industry for the digitization. Why people are talking a lot about sustainability is more about carbon capture, is more about CO2 emissions, it's about the energy, right? And of course the circular economy, right? It's not only just India government, but everyone is very conscious about the plastic waste, right? And how do you do the circular economy to make sure that we minimize the waste, right? And at the same time, companies are more looking into operating digitally, remotely, right? And that is something, the concept of self-autonomous is coming into picture, and industry is heading towards that. So I will give an examples what Aspen Tech is doing in self-autonomous plant in the industries, as well as how this AI, artificial intelligence, machine learning, all these are coming into picture, and they play a very vital role in the process industry. So this is my sort of topic today. And of course, please feel to ask fundamental questions as well on an Aspen Plus and HYSYS if you have. But my presentation will be beyond that as well, right? So I'll be covering these topics with the right industry examples, applications, as well as the case studies from the real industry examples, be it from companies like Reliance, ExxonMobil, Shell, or you name any company where you will have a Aspen Tech software. Okay. All right. So, sir already introduced, but this is my brief introduction. I thought to put together because I think there will be most of you know me, but I thought to give a brief introduction about myself. So, I'm a process engineer, and I feel proud myself. I'm an alumni of PVPIT as well as TKIT, as sir rightly said, and I'm always associated with my universities and the colleges as well. But that's yes, my basic degree is chemical engineering. After that, I work in operations in Galaxy, as rightly mentioned. Then I work in Sulzer for process design of distillation columns. And then I switched my career into process simulation with Honeywell for about 3.5 years. I spent most of the time in Honeywell, Singapore during that time. And last 15 years, right, precisely in this month, I completed 15 years with the world's #1 process simulation software company, which is Aspen Technology. Okay, and my area of expertise is not just simulation now. As you can see, I'm doing a lot more things beyond that, like digital transformation, sustainability. Recently, I'm taken a role for introducing AI ML into the process industries, right? Then, of course, I do a lot of process consulting, business consulting to improve the business performance, energy management, and so on. Of course, being it's a commercial company, of course, I need to take care of business as well. So I'm also handling the business development and key account management. Here are my contact details. You can note down my email ID and phone number if anyone wants to reach me. But please feel to take down my contact details if you want that. With this brief introduction, what I want to share is my personal experience in this industry, right? Being in Aspen Tech for last 15 years, right? What I'm actually looking in the industry, what changes are happening, how do we bridge the gap between industry and academics, right? What are the expectations from the industry, from the academics, and what improvements we can bring in. At the same time, what is the key role of process simulation into the process optimization industry? Okay. So that's my brief background. Okay, so one question you may have is about whatever I'm presenting, will it be made available to you? Of course, as I already discussed with Professor Patil, US Patil sir. So I will make sure I will give a copy to everyone so that later you can review it yourself as well. Okay, so let's move from here. So this is a standard disclaimer. I want you to read for a minute. The reason I want to share this or put together because it is mandate for me from my company, because some of the information I'm sharing here is of course confidential to my company and my role, but because this is an academic seminar, of course I feel proud that I should share some of the key industry aspects and the innovations happening. This disclaimer is whatever I'm going to talk is basically is about our product development, design, architecture, interfaces, and so on, right? It's represented solely from Aspen Tech, right? It is only for today's discussion purpose, right? Of course, it's a commercial disclaimer, but I need to show it for before any presentation. Okay. With this, let me start now. Okay. So I talked about my topic. I talked about my brief introduction about myself, and with this disclaimer, let me start. About my today's presentation. Now, I want to start with the brief introduction and background about the Aspen Tech, right? And the reason I want to share, it's not that I want to do any presentation about my company, but I want to give a flavor to you because most of you may or may not aware what is about Aspen Tech, right? And it has a very close, the DNA of Aspen Tech is actually, it came from universities, it came from students, it came from professors. And most of you may not aware, that's what I thought. In fact, yesterday my presentation was ready, but I just introduced this morning. I thought to give a flavor that people should know where from, what is the background history of Aspen Tech. Okay, so I want you to take a minute to look at these pictures. Okay, so you guess what this picture from where this picture came from, right? It obviously looks like an university or maybe an parliament building, something like that, but I'll comment that in a minute. But you guess what it could be. Obviously you see my picture in the middle as well, where I already visited there a few times, right? But I'll come to this picture again. But any guesses from anyone from what this picture is from, right? Can anyone comment? Is it any university, any college? If you know if it's any university, which university it's in? Yeah. Someone responded? You can unmute and answer it, or you can chat it if you know about that. No, no one.
So someone has responded in chat box, and that is MIT.
MIT. Okay. What? Which MIT? There are many MITs, right? So we have MIT in Pune, and there is MIT in US as well, right? Okay. So this is MIT, right? It is Massachusetts Institute of Technology. But let me come back this picture in a minute, right? So there's one more question from you, and I hope you could try to answer that as well. What is actually Aspen Tech is about? I know it's a company. It's a company now listed in NASDAQ. It's a well-known branded company, #1 in process simulation. But what it is about Aspen Tech? Can anyone try to gauge what is Aspen is about? Yes, Tech stands for technology, but what is Aspen is about? And it has a very close, as I said, it has a very close association relationship with university, academics, professors, and students. Can anyone type in chat or unmute and answer what does word Aspen stands for? Does anyone know about Aspen Tech? No? No answers? Okay. Okay, that's fine. So let's understand what is this Aspen about. So word Aspen actually came in from a actually is an acronym for Advanced System for Process Engineers. Okay, so that's the word Aspen actually came in from. Actually, if you Google it, you will find there is a tree called Aspen as well. But originally the word Aspen came from this project where it is acronym Aspen from Advanced System for Process Engineers. Okay, now with this clarification about what is Aspen Tech, let me go back to this picture. So you saw these pictures, right? So this Aspen Technology company, founded by a renowned professor in MIT, Larry Evans, in 1970. Okay, as you can see, I highlighted here. So this company, you see this first picture. Let me see if we can get the, yeah. If you see this first picture, the original MIT building, right, where Professor Larry Evans, he was in head of chemical engineering that time. He actually did a project there in MIT back in 1970, right here. So he was a founder actually of this company, right? He was a professor during that time. Of course, he retired now. Now, what has happened around 1970s? There were energy crises in US, and many industries and academics came together that how do you address the energy crisis, right, in the industry, right? And as part of that requirement from the government agencies, from the industries, as well as from the academics, right, Professor Larry Evans with his 5 students, he actually did a project that time for energy management. So that was a simulation program they developed in Fortran, right? And with that, actually, once that project completed, they got a good response from the industries. Everyone were after them to modify that program for which suits the different industry requirements and so on. And with that background, they actually named that project as Aspen. So that was in 1970s, and until 1991, the Professor Larry Evans, Dr. Larry Evans, he was doing consulting through MIT using that Aspen program that time, and that was nothing but an Fortran code during that time. So until around 1980s, the Fortran code of original Aspen was available in the public domain. Later, what has happened, looking at the demand, and then he thought to let us commercialize that. And in around 1981, he actually founded a company in MIT itself, which is called Aspen Technology, right? So this is an original MIT University in Boston, just across the Cambridge River. So this is sitting on a Cambridge River bank. So there is an MIT building, and in this MIT building, there is an there is an Aspen lab. So originally, when there was this program was founded, there's a Mac computers, big computers, and all that. It is still available there, right? And of course, so he was then he actually quitted from MIT, and he was like a CEO kind of role for many years in Aspen Tech, right? And of course, he hired many industry people, academics, expert, and so on, and that he has commercialized the company. And then the first software which was released by Aspen Tech was today known as Aspen Plus software, which is a first principle thermodynamic simulation software. Okay, and over last 40 years, this company has grown from 1% or 5% from that MIT. So out of those 5 people, right, 5 students and Professor Larry Evans, right, so 3 of them are still working with Aspen Tech. They are around 70 plus, but they are still working with Aspen Tech. Okay, later you might see some pictures of them which I'll show, but 3 employees are still with Aspen Tech from the original founder members. Okay. And of course, as I said, it has become commercial software, and then company keep acquiring more softwares. They develop the interface, no more Fortran code. It's a GUI based software, easy to use software. A lot of innovations happen. A lot of money has been pumped in, R&D has been done, and so many things has done by Aspen Tech. And today, that one software company founded in 1981, now we have almost close to 200 softwares which we offer for the process industry. So that's the journey of Aspen Tech, right? So started with one software developed by Professor Larry Evans with his students, and they renamed it as an Aspen Plus when they founded Aspen Technology. Of course, he retired after a few years and he handed it over to the investors, and now it's a commercial company, no doubt in that. But then, but the innovations, the deep domain experience, the fundamental of chemical engineering is still in our DNA. So if you ask me, the engineers working in our company, right, who are they majority? So majority of them are chemical engineers. When I say majority, means almost 90% are chemical engineers. This company is founded by chemical engineers. Today also we have by chemical engineers, and we work only with chemical engineers, right? Of course, we do have some software developers, and it is required in today's generation to maintain the update the software. And also recently, as I said, we are entering into AI ML, so we also have some data scientists recently hired, but purely it's a chemical engineering company. Okay, and those are some pictures, right? So I'll go back to the pictures again just to show you. So this is an original MIT University. There's an MIT Aspen lab there. So I did visit there a few times, right? So this was my picture from my last visit around 2015 or 16. That was actually snowing there. You can see snow around there. And one good thing, what I like, once we go there, there are the students who will take you through around the university. It's a very huge university. You will need at least 2 days to come to go around and to see each lab, library, the students, and everything. It's a very huge campus, very huge campus. So it takes almost 1.5 to 2 days, right? And you see the snow around there. So there was an Indian student, that girl, she actually took us around and showed, and in fact I spent a lot of time on the Aspen lab. So that's the background. So I thought to share with you because you should feel proud, because the foundation of Aspen Tech is actually from the university. All right, with this background of Aspen Tech, let's move on. So what is about our company now, right? So as you can see, it's a very niche company. Although we say it's a software company for process simulation, but very niche. You see, worldwide we have only 1,500 employees, right? And out of 1,500, this number is a bit old, but more than 200 people are PhD degrees, and are almost rest 80% are masters and above, and rest all 20% are the other people. Right, so it's a very professionally driven company with a very deep domain expertise in the industry from academics. I will keep repeating academics because I'll come to that in a while, how academics plays very important role in development of software as well as development of the applications. Okay, and with that background, then of course that Fortran code is now converted into flowsheet simulator. It's a desktop tool now. Then we also have into predictive controllers, which is advanced process control, and so on. So a lot of things have happened. Later you will hear from me about this, right? And regarding customers, right? Typically when I do presentation, people ask me, who are your customers? And my answer would be like this. Okay, you name any chemical industry, whether it's a small, large, whether it's an upstream company, refining company, midstream company, EPC company, design company, whatever, you name and you will find Aspen software. I mean, it is like a must to have tool, not like it is like good to have tool, right? So any industry today, whether it's a operations company, it's a maintenance, or whether it's a design or EPC, they will have our software. So I need not to mention, but if I had to really look at it to the top companies, right? Top 20 large ENC companies in the worldwide, When I say large ENC, like I can name few like Technip, Jacobs, those are our clients, right? When I say petroleum companies like Shell, Reliance, ExxonMobil, and so on, they are our clients. Chemical companies like BSF, SABIC, Dow, right? So they are our clients, right? So our roots goes to across all industries actually, right? And you can see our innovations, right? So 40 years we are innovating the products. We have more than 200 patents. This was a bit old number, but 200 patents registered and so on, right? So we have two R&D centers, one in Boston and one in Houston. Both are in USA. We have 35 offices across the worldwide, but those are more like a support, technology, sales, consulting, and so on. But the key development happens only at two places, one in Boston and one in Houston. And historically, they have been there because of the talent pool our company gets from the MIT and the other universities from the USA. Yeah, so what you can do, see from our company, right, by number, because being a simulation company, the profit, the value, the benefits are important for us, for our customers, right? So we have created more than 50 billion value to our customers, meaning our customers all put together already achieved a savings of $50 billion, which is significant number, right? All blue chip companies are our customers. You name any company. Just to give an example, if you want to name companies in India, be it Reliance, SR or Naira Energy, BPCL, HPCL, CPCL, Indian Oil, EIL, Technip, L&T, all these blue chip companies are our clients, right? So there's not a single company who don't have Aspen software today. I talked about employees, right? By the way, from India perspective, we have office in Pune. I personally, actually, my role is for Asia level. I look after complete Asia Pacific business, but by choice, I decided to work from Pune. That means I am in Pune during at the weekend. Rest of the time I'm traveling. But we do have an office in Pune. We have about 42 people operating from Pune office. And we are a leader, right? Leader in the technology and industry in this process modeling and optimization. Yeah, so what is important from Aspen Tech? The importance for us is not to develop a software and just dump it to our clients, right? The important is about our customer success. Meaning when we develop a software, we ensure that our customers get the benefit out of that. If they invest X amount of dollar, we try to make sure they get 5x in return, right? Or 10x in return, 20x in return, right? And as I said, with our deep domain experience, when I keep saying deep domain experience, meaning a fundamental chemical engineering, right? Because process simulation, one can learn it, right? I mean, it's like a simulator, desktop-based application, Windows-based application, and any engineer can quickly learn it. But the important is about using the chemical engineering inside that, right? So we apply our knowledge, not just technology, which is very important for us. And you talk to any Aspen Tech person, you will find that, right? For us, importance is the fundamentals and chemical engineering, right? We are very innovative. Every year, we invest roughly around $500 million into innovation and R&D. We invest in customer challenges, meaning we try to address very complex problems, be it a small or big, doesn't matter for Aspen Tech, but we try to address any complex problem of industries, right? And we ensure that we help our customers to achieve the operational excellence. So that's important. So I already briefed about that. We are #1 in market share, and you can Google it. You can go to any reports or search reports or reports from companies like ARC, McKinsey, and try to find out Aspen Tech's market share or that. You will find Aspen Tech is #1 in any segment, be it a process simulation, it's a process control, supply chain optimization, and so on. So you will find that Aspen Tech is #1 in the industry. Okay, and those are some clients and the key clients on the right hand side. Okay, what is uniqueness to Aspen Tech, right? So the key thing for Aspen Tech is basically a deep domain expertise, because you will find many commercial simulators in the industry, but what is important is whether those simulation software has this domain expertise, right? I mean, what I really mean, if I have to design a heat exchanger, I can simply use Q equal to mCp delta T equal to UA delta T, right? I mean, these fundamentals won't change, but I'm really applying that. I'm accurately calculating U. I'm accurately calculating the area. I'm rightly sizing the exchanger. I'm rightly sizing the column, right? It comes from the domain expertise, not from the software, right? Software is the end of the day, it's a code, right? One has to develop it and use the algorithms to solve the equations. But the important is the domain expertise, right? We solve the complex optimization problems, right? We love it actually. Aspen Tech loves to solve the complex problem, right? We have a track record of innovation. We have breadth and depth of mission critical solutions, and we are hardware and platform agnostic, right? We really don't care about what platform or hardware customer is going to use, meaning whether they use a Dell server or whether they use a platform like Windows or Linux. We are hardware and software, hardware and platform agnostic actually, meaning we try to support all the softwares and hardware. And most importantly, the last bullet point, ROI. ROI stands for return on investment, right? So we measure on value, right? So when we provide the software to our customers, right, the first thing and the important thing what we measure is the what value customers are getting out of it, right? And that is the way we measure success. It's not that how many copies of licenses they have, but for us important is how the value they are getting today, right? So these are some uniqueness of Aspen Technology, and because of this, in fact, right, it's a number one even today, and it will remain number one. And of course, you will hear from me about a lot of innovations and a lot of R&D and a lot of new developments. What all are we are doing here is important. Okay, just to briefly share, because this is a report from ARC, is an advanced research company. So it's basically is a third-party company who does the research on the various simulation platforms, right? So you see the market share. So number one is of course Aspen Tech, almost $1,000 million, $1,000 million annual revenue, almost 35% share we have, and rest all you see in the range of single digit, 4, 3, 3%, and so on. Even our immediate competitor Honeywell is far away from us, 2.5% versus 33%, right? So that's strength of Aspen Tech in the industry. Okay, and you see the curves, right? This is again a published graph. You can Google it, you'll find it, right? So you see the Aspen, the business growing and growing and growing, and it will continue to grow. Whereas other players, you see there is a downward trend already in the market. So some of the other simulation companies who offer simulation softwares like Aviva, KBC, KBC now acquired by Ikogawa, then Schlumberger, Honeywell, and so on, right? But see the gap here, delta. It's a huge, right? And there is no way they can come to closer now, because we already have an established customers, established market and software, and it is not just established, it is hard to replace that, right? No one can come to closer, because that's the strength of softwares we have. Yeah, so again, just a brief to summarize about Aspen Tech. So powerful technology, right? So as you can see, Aspen Plus is our gold standard, right? Why it's a gold standard? Because we are the company founded in MIT, and our key strength are the physical properties. Because any simulation, unless you have the right properties, right, no matter how good you are into solving the equations, and no matter how good you're putting together a flow sheet, unless the properties are accurate, you won't get the accurate results. So our key strength is properties, right? So later you will hear from me what I mean by properties. But the most important is, it's not about the known component like hydrocarbons, methane, ethane, propane. One can easily find the properties. What about the chemical component? What about the components or mixtures? What about the solvents, right? So that's our gold standard, right? So the accuracy of our properties are in the is actually close to 100% or almost 100%, right? Innovations, that is our uniqueness, right? We continue to develop the software, continue to innovate, and it's not that I'm just saying that. Later you will hear towards the end of my presentation about recent innovations and so on. Okay, trusted and proven, this is what market leading solution software. And as I said, top chemical, pharma, whatever you industry you belong to, you just go and see what software they use, you'll find Aspen Technology. And we are flexible in the sense we can handle all types of processes, be it a continuous process, be it a batch process, be it a polymer, it's a solid handling, electrolyte, right? It's an upstream oil and gas, crude distillation processes, or it's an hydraulic studies, equipment sizing, whatever you want to do in chemical engineering, is everything is done using Aspen software. It's not just one software, as I said in the beginning. It's almost like 150 softwares we have today. Okay. So we believe that optimizing asset performance in complex industrial environment makes the best companies even better. Meaning, what we believe, not just to solve one problem in the industry. Suppose there is a pump issue, suppose there is a column flooding issue. We don't solve the one problem. We don't just fix the one issue. We don't fix one equipment. We look at the entire asset, entire plant, and we look at a time, right? If the problem occurs at one place, we will make sure it will address all the other problems in the plant. That's what we make sure the asset performance, right? Asset meaning a plant. Okay, we are not talking about equipment or a process unit, right? We are talking about assets, and this is the key word. Okay, from me you will hear later today. Asset meaning the entire the plant. Okay, and software and insight that run asset faster, safer, longer, and greener. These are the keywords, right? So why these softwares are meant for, right? It is to ensure the assets are faster, time to market is quick, they are safer, safety is prime importance for us, longer, because the life of the plant is also important. Not like historically people used to run plant 15-20 years and there was a revamp required and a lot of changes, technology changes required. Now people are looking 50 years, 60 years, right? And most importantly, greener, right? Low emission, no pollution, right? Sustainability. So these are the key things what we actually keep in mind when we design the company, when we operate the company, when we optimize the asset. So these are the key things from us. Run the asset faster, safer, longer, and greener. So these are the keywords from us. Okay, I'll pause for a second. Any questions from anyone before I talk about this slide? Does anyone have any questions? Any comments? No? Let me see in the chat window if there are any questions.
Presently, no questions, sir.
Okay, thank you. No problem. So let me go back to presentation mode again. So you see the university professors here, right, in this picture. Are you familiar with some of you? I hope so, right? At least the first one, second one. You have seen the books, right? We are using already, right? Stephanopoulos, Professor Klein, Professor Rakesh Agarwal, right? Professor James Rawlings, and so on, right? So why I'm showing this, right? So Aspen Tech, although I say it's a company for a process simulation for, and it's into commercial software, right? We have a very close association with academics. Okay, so we work with the top-notch universities across the world, and these 6 professors are on the academy. So we also have what we call Aspen Tech Academy. Okay, so Aspen Tech very closely work with these professors in taking their advice, taking their consulting, and very closely work with them in development of the software, right? And some of these professors, I think I actually myself use the books, right? Stephanopoulos and Klein and others, right? So they are on our what we call industry academy advisory board. So they come together with us, and we invite industry leaders, and we discuss at least twice or thrice a year what are the best things in the industry happening, what are the best practices are happening, and how do we bring in that into the academy. And to get this benefit out of that, right, what we have done, you see this website link. Later I'll send you the link. If you go to our website and you put a slash and put academic/program, there are actually the academic programs available for you to download. And you can actually, the professors or teachers or the universities can use it to teach to the students, and those are developed by these renowned professors. Okay, and in fact those courses are also same, whether it's an MIT or even in a university in India or in Europe or Middle East, any region, those are same. So it is available today. Of course those are fundamental courses, but those are very useful. But the point here is these professors are actually working with us very closely in development of softwares, as well as giving us an advisory, and we actually back in work with them, making sure that we translate our development innovation even to universities and the students, right? I personally met all of these 6 professors at least twice or thrice, specifically Dr. Agarwal and Klein and Stephanopoulos I met actually 3 times, and I found them I very interactive, very good sessions I had with them on process development and process simulations with them. Okay, and they do have books, in fact, right, on process simulation and process optimization. So one can refer them as well. So we have very close association with academics as well. All right. So let's move now presentation in little different stage now. Okay. So let's look at industry. Okay. So what is happening around the industry, right? This is very important to look at the industry outlook now because it has been changing, right? Especially last 1 year after this COVID-19, the situation has been drastically changed and it is still impacting us, right? Not just process industry, even our day-to-day life, yeah, even the other industries, whether it's in healthcare, whether it's in automobile or whatever you get, see, it's impacting. What is happening around our industry, which is process industry? Okay, so I segment into the three categories: ENC, which is EPC or engineering and construction company; energy vertical, which is upstream, refining, midstream, and so on; and chemicals is mainly categorized as petrochemicals and polymer and spec chem and pharma industries. Okay, so what is happening? You see, industry is showing signs of rebound, right? Meaning the capital spend was drastically reduced in 2020, but now it's slowly tried to recover, right? Now, why it is drastically reduced? Because that is actually directly proportional to the crude oil prices. If the crude oil is fluctuating from $20 to $80 to $100, that's a huge fluctuation, right? And the entire process industry actually depends on the crude oil, right? So that is the key thing, that capital expenditure went down. The moment capital expenditure goes down, it impacts other industries. It impacts on the projects, it impacts on the people, it impacts on the technology, it impacts on the solution, licensor, catalyst, everything, right? Of course, we see some increasing demand in investment decisions by owner operators. For example, projects which are stalled last year, now they're slowly coming up, right? Just from an India perspective, you all know that we have public sector refineries like IOCL, BPCL, HPCL, and of course private refineries like Reliance and Naira Energy. But Indian government is pumping a lot of money in the Ratnagiri refinery, right? They call RRPCL. Of course, that's a land issue still there. That's a political thing. But then again, that's a capital investment decision, right? One of the largest grassroots refinery coming up in the world, right? Almost like 75 MMTP capacity, right? And the investment is in the tune of $40 billion. So you can imagine how many employment it will create, how many chemical engineers will be required for that, right? I'm very closely working with that company right from the concept level in the design stage, right? So what I'm trying to show is here an example of the investment coming up, right? And that's a bright future, right, for us. So seeking digital initiatives, and this is very key thing right now. No more people want to do the paperwork, right? Everyone, including whether it's a design, whether it's an operation, the key things now happening in the industry are digital initiatives, right? People are looking more of a digital things, and what I mean by that I'll explain in a while. Okay, and of course the work share. This is very important, right? Workforce, the skills, the talent availability is very important. And how do we share the work across offices, right? Even the refinery is coming somewhere in the West Maharashtra, but the office in Mumbai, the people working at a different places, the technology companies at different places. How do we share the technology? How do we collaborate across all offices and so on, right? So these are some challenges industry is looking into in EPC space. In energy, which is in operations, in refining, most important is the sustainability. What is sustainability? Is about environment. It is about carbon capture. It is about energy, right? It is about emissions, right? And this is concerning causing shift, right? Because governments, not only India, every government, including India, is tightening the norms now, right? You see, we used to get gasoline, petrol, in Euro 5 we used to call Bharat 5, Euro 6, now Euro 7 coming, Euro 8 coming, right? So norms are being fixed by the governments, and that naturally puts a pressure on the industries, right? Meaning they have to advance the technology, they have to change the catalyst, they have to upgrade the the equipments, they have to redesign the equipment. So that's actually comes in together with the sustainability issue, right? And this is going to be there, right? So key thing in the industry, people talks about the sustainability. Crude oil fluctuations, I talked about this, right? Now it's okay in the range of 60-70, but it went back all the way up to the $20 to $15 per liter per barrel, right? In fact, you might heard the situation in Canada, right? There are gas wells where people used to pay to the buyer to actually lift their oil, right? So that was so much of excess oil were produced, right, in Canada in the pandemic period. And workforce demographics, right? So this is actually changing the requirement. Workforce demographics. Most of the Indians we know, right, they work abroad, in Middle East, in US, in Europe, in even Korea and Japan. I met a lot of people from India across the demographics because we have a talent pool and so on. Another keyword in the industry which you are hearing, which is called C2C, meaning crude oil to chemicals. What it really means, right? Typically, refineries produces the fuels, which is gasoline, kero, diesel, naphtha, right? All these fuels. But then now the demand is saturating, right? So because there is not much of energy demand coming because of people are moving for the solar energy, hydrogen energy. I mean, everyone is looking after green energy now, right? And of course the automobile is not growing the way it should be. That's why the fuel demand is going down. But at the same time, the chemicals demand is going up, meaning there's a demand increase for plastic, demand increase for furniture, demand increase for the various things, for crafts and so many things. That's why companies are looking, how do I convert crude to chemical directly? Crude to chemical is even today it's a process, but it goes to crude to fuel to naphtha to chemicals. So it's a lot of crackers required there. You have to crack the crude into the multiple units to get the final chemical, right? But now India, the first plant will come crude to chemicals is at Reliance. Okay, we are working with them. But companies are looking, how do you convert crude directly into chemicals, meaning the end chemicals, right? Today people generate naphtha, propylene, but then how can we get the further derivatives of those chemicals? That's people are looking into. And finally, about chemicals, right? Okay, this industry, including pharma, in fact, they are doing good, right? Although there is an impact on energy industry, but chemical industries are doing good, especially pharma industries, right? So their demands are increasing. You see a lot of forecast has been there for them to increase. Although there is a plastic ban coming up, but people are also looking into recycling of plastic, what it is called circular economy and so on. Right, so this is again getting up. Again, digitization is the key thing in the chemical industry. Companies are also looking into some global trade uncertainties, especially ban coming from China and other countries, right? And of course, the competition, right? For example, what is required is PET, right? PET, as you know, it's a common polymer component which is used for this water bottles, right? You can imagine how cheap it is, right? Because if you get a liter bottle at 20 rupees, right? Obviously, it is manufactured that water. It's a margin there, but then bottle cost is hardly like few paisas, right? So that's how it's getting cheaper and cheaper. But at the same time, demand is going up, right? So that's happening in chemical. Of course, need not to mention pharma, right? Pharma sector is definitely booming up. Of course, that may be a pandemic impact, but at the same time, the demand is also increases globally overall as well, because health consciousness and a lot of other factors coming up there in pharma. This is industry outlook. Okay, coming back to the industry, what companies are looking, right? Companies are not looking now into design of an equipment, optimizing an equipment, or troubleshooting an equipment. When I say equipment, I'm just talking about a pump or heat exchanger, compressor. No, companies are looking at asset optimization. What really an asset optimization is about a complete asset, which includes a plant, it includes the operation, which includes the maintenance, feedstock, raw materials, supply chain, and everything. How do I optimize everything? Let's say, just to give an example, if there is a demand for certain liters of gasoline from the retail outlets, right? How does it back calculate how much is the crude required? What is my production capacity? What would be my feedstock? What temperature process parameter should be set in, and etc. etc. It is end-to-end optimization. That is what it's called, asset optimization. So we divide that into three categories. One is the design, pushing the boundaries of a design, meaning getting maximum out of your design. Then operating at a maximum limit, push the limit. Even the capacity is at 100%. Even the heat exchanger is designed to give a heat duty of, let's say, 100 kilowatt. How much I can get it? 120 out of that. And maintain it. Maintain it without any failure is the keyword, or is important in the industry. Because no matter how good you are in design, no matter how good you are a chemical engineer, how good you are expert in your domain, no matter how good you are operate a plant, the equipment fails, everything stops there, right? It's like a human being, right? No matter how good you are in health, you might be doing daily exercise, you might be a health conscious and etc. But one thing, if there's a small blockage in heart, actually impacts everything. It's the same thing in the industry, right? So maintenance is very important. So that's why Aspen Tech said, no matter how good, Aspen Tech used to say we are a process industry, process optimization company. We no more say that we are process optimization, because we realize no matter how good you are into optimizing the process, at the end of the day, your equipment should be healthy and keep running. Same like human being, right? No matter at what level in my career, unless I am a healthy person, right? So that is the logic behind it. And with this, I'll just briefly show one video here. Just confirm me if you can see that.
Sir, no audio.
No audio?
Yes, sir.
Madam, sir, please mute your audio so that the video's audio will be clear.
Yeah, you see the tagline here, technology that loves the complexity. Sorry, sir, there was audio issue at the beginning. You could hear it, right?
No, so the audio will not able to hear.
You could hear, right?
No, sir.
Or you could not?
Entire thing we could not hear.
Oh, is that? Okay. Let me try again. This is just a short video. Yep.
No, sir. They are telling mute your speaker.
I'm muted actually. Okay, let me see different way.
But please unmute and talk.
So please unmute yourself. Madam, Sarana Madam.
Okay, can you hear me now?
Yes, sir.
Yes, sir.
Okay. Let's continue. So you can see the video later. But what I was trying to say, or that video was actually representing that this is very important to look at the asset optimization, not just the equipment or not just a process unit. Okay. All right. So if you look at the typical what we call an architecture of an asset optimization, right? So there are few things, right? One has to look into it. Is about plant digital twin. Is about design, then design and operations and debottlenecking, then planning of a process, planning of a manufacturing, and scheduling at a macro level, right? Next, controlling the plant, optimizing the plant to making sure to deliver the maximum quality as well as the yield, conversion, and performance. And at the same time, most importantly, as I mentioned, the reliability of the plant as well as the making sure there is no unplanned downtime, meaning there's no breakdown or failures all of a sudden. That's what I said, right? If at one end I might keep optimizing the plant, but if there isn't a failure, everything stops. Right now, what this slide actually shows, basically, there's a vertical integration as well as horizontal and across, right? So the most important is one should look at the holistically the complete asset, right from design all the way up to making sure that there's a maintenance which is unplanned. Sorry, the maintenance which actually reduces the unplanned downtime, right? Despite, for example, despite keep maintaining the equipment, right? Same like our cars, we do regular servicing and everything, right? But there could be an uncertainty, something fails, right? And then it becomes a troublesome at a certain point, right? So how do we avoid that? So that is what we call it as an asset optimization life cycle for any process plant. I'll give you examples of this so that you will understand more detail. Let's start from design. Okay. So this is an important slide. I want you to pay some attention to understand this little more detail, and it is very helpful for in your academics as well, right? So when we look at the process industry, be it a chemical plant, refining plant, or upstream and midstream industry, there are two things about the plant. One is about designing, and second is about maintaining and operating the plant. So left side represent the design, and right side represents the operations. Okay, so what are the key elements of that? When we do the design of a plant, right, we have to make sure we develop a design, we do the conceptual design, then develop a feed package, which is called basic engineering, then do the equipment sizing and design, and from there we do the economic evaluation. Economics is also important. It's not that, okay, my process is excellent, very good, high ROI, high yield, etc. But if there is no ROI, no one would invest in that, right? So economic feasibility is very important, same as the process feasibility and the safety feasibility, right? And most importantly, because of this tightened norms from the government, safety, emissions, environmental, and energy are very important things. So these are the aspects of the design, right? And from there, when we move to the operations, right, when the asset is handed over to the operations, right, then most importantly is the troubleshooting. Operations improvement, troubleshooting, revamping of any unit if it is required, as well as making sure there's enough training is available for process engineers and the operators in the plant, right? Because they should be trained in order to run the plant effectively and efficiently, right? So if you see this white lines here, arrows, right, those are interconnected. So all of these workflows in the process industry is interconnected, right? So the engineer, the chemical engineer, process engineer who does the design, he should be able to digitally transfer the data for equipment design and sizing, should be able to develop the basic engineering, should be able to do economic sizing or economic evaluation, safety studies. From there it could be able to develop OTS and so on, right? So what it really means, it really means that this is an operational excellence workflow which creates a value for our customers, right? So using Aspen softwares, these are the key applications one can do seamlessly, digitally, end to end. meaning starting from a process development all the way up to the ensuring that process is running smoothly without any disturbance at a maximum steady state level and no failures and no downtime, right? So these are the key activities, right? And while doing that, most important is it's a digitally transferred technologies and the models, right? And you see some of the benefits here, right? The benefits ranging from certain percentage of reduction in capital, in energy. For example, at a concept level, if you use the technologies, right, the savings in capital energy from 5 to 20% is significant, right? Similarly, reduction in engineering design efforts, 30%, significant, right? Reduce the flare loading, which actually reduces your emission, right? Reduce the emission, then revamp, reduce the capital, reduce the energy, right? Increase the capacity in debottlenecking, save the certain cents per barrel, right? So these are the benefits, right? As a consultant and engineer, when you talk to the industries, and if you just talk about the solutions, no one will accept that, right? What people wants to say, they want to see the number. I just had a meeting with one of the Reliance board members just last week, right? And I was a presenter, and then of course we knew what they expect being Reliance, right? They are very their commercial mindset. My presentation started with a headline saving X amount of X dollar savings per barrel, and that's how it started the discussion. Otherwise they even would not have given the meeting to us to present as well, right? So important from industry is the benefit, savings, value, not the technology and not the platform. But then if the technology translates into value, it improves the workflow, it improves the digitization, of course people will welcome that. So be it in a design stage or optimization or the plant operations, whatever stage you are in the industry, the important is how the technology gives return on investment. At the same time, the seamless interface, seamless data transfer, right? You remember people used to do, like, if I am a process engineer doing a design and there is a mechanical engineer doing heat exchanger design, okay, I used to take a printout, send it to there, and he will mark it with a color, and then they will, okay, this area is different, let me redesign it, right? All that used to happen, right, in the past. Of course, some companies still prefer to do that manual handoff, right? But in the today's environment, in today's pandemic, in work from home environment, how it is going to work? It is practically not possible, right? And then it leads to error, it leads to the efficiency, lesser efficiency and things like that. So that's what digitally transferred the data, digitally transferred the technology is very important. So just to give more specific example, I'll come back to this slide. You see this another architecture. This is more about Aspen point of view, right? What I showed earlier was more of an industry point of view. But when an Aspen point of view, when I'm doing process design and conceptual design, we have two process platforms, simulation platforms, right? One is called Aspen Plus and second is called Aspen HYSYS, right? So we have two industry-leading process simulation softwares. And since I'm on this point, you may have a question, what is the difference between Aspen Plus and HYSYS? Actually, both are process industry simulation softwares, but Aspen Plus is more designed to simulate the chemical processes, chemical, petrochemical, pharma, as well as spec chem. And HYSYS is more for energy industries, which is refining, upstream, oil and gas, and so on. Okay, so irrespective of whatever platform you use for simulation, once you do that, how I'm going to do equipment design, how I'm going to do the safety analysis, how I'm going to do the economic analysis, how I'm going to develop the data sheets, how I'm going to develop the PFDs, how I'm going to develop the PNIDs, right? Because just simulation would give you equipment sizing and heat and mass balance, right? But that's not just enough, right? So then from there, one can transfer the data into exchanger design and rating, where you can do the heat exchanger sizing, you can do the shell and tube heat exchanger design, you can do air-cooled heat exchanger design, you can do TEMA design, right? You can do the plate fin exchanger design, size it, and again check back into simulation those are feasible or not. Then you develop a basic engineering package, which includes develop the feed, you develop the PFD, PNIDs, data sheet, line list, instrument list, and so on, right? From there, you do the cost analysis, right? If I'm going to put a plant of this capacity and this size, if I'm putting a plant in India, what it would cost us? What is the operating cost? What is capital cost required? If I put the same plant in India, in Mumbai versus, let's say, some other place in India, Chennai, what will be the difference in cost? because one has to do that ROI analysis, right? So Aspen has a software to do everything actually, and this cost data software also has a cost data bank, which is a which very frequently updated in the database, right? And then of course, how do I use these models to support my operations, right? Because once I use the software to design, I should be able to use the same thing for operation optimization as well, right? How can you use the same models in online applications? I can use it to optimize the plant and also for refining operations and so on, right? And then some third-party technologies. For example, typically drawings are generated in tool called AutoCAD, Bentley, 3D, Hexagon, right, and so on, Smart Plant. So Aspen softwares are also integrated with third-party tools as well, right? So what it shows in entire process engineering workflow, at every stage there is an Aspen software. Of course, each software is a different, right? But we do not sell any single software as a single software, right? These all entire comes as a package so that process engineers can do everything in one single platform, right? So they don't have to really depend on a different discipline, or they don't have to really work in silos, right? Or manual data transfer or the paperwork and so on. That's a key thing in this engineering optimization. Okay? So with this approach, you remember I explained this earlier, right? This is an integrated operational excellence workflow, and these are the tools used to do that, right? So you see the value created, right? So this is a classic 3D picture of a refinery, right? Right from CDU, where crude comes in, it goes to a downstream unit like naphtha cracker, fluidized catalytic cracker, coker, hydrocracker, so on, and it finally goes to the tankage where you have a gasoline, naphtha, kero, then blending happens, and then you have LPG from the top and so on, right? So what is important that with this step, you see it provides the benefit to the plant to save energy at certain percent, 2 to 10%, reduce the startup time, avoid the emission, or in other words, reduce the emissions, safety, turnaround cycle time, and so on. And at the same time, you see the benefits. These are typical benefits achieved in the refinery industries, right? All put together, what companies are looking is the gross operating margin, right? When they publish their annual report to the stock industries, to the government companies or government agencies, right? They have to report the gross margin, right? And the performance of any company depends upon how much is their gross operating margin. And that all comes from optimizing the asset, optimizing the process, using such technologies. And if I had to illustrate this with examples, you see these examples, right? Whether it's a BPCL in India, then Hanwha Total in Korea, or Cepsa in Europe, Hyundai Oil Bank in Korea, Inos in Europe, Ersoil in Korea, KNPC in Middle East, Kuwait, SK Innovation, Saudi Aramco, right? Number of examples I can put. Now, why we can confidently share these company names? Because these companies are actually published papers. We call them as success stories, and we are allowed to use those papers to publicly talk about that, right? Because people learn from peers, right? So, for example, BPCL can learn what Tupras is doing, right? Cepsa can learn what Ineos is doing, and they share each other the best practices and try to adopt the technologies. Okay, so that's the performance engineering workflow which I talked about. Okay, now moving forward, let's come back specific to some industries, right? I will take an example here for petrochemical, chemical spec chem industry, okay, which includes pharma as well, right? And our gold standard software for pharma is Aspen Plus, right? So what is this about Aspen Plus, right? It is not just a steady state simulator. As I said earlier, this software is about the properties, and we have about almost 28,000 pure component data bank in our software data bank, which is very important to have it, right? So when I say 28,000 pure component, meaning you'll find 28,000 components in the data bank with its properties. And we do have NIST and deeper data bank available in the library. So NIST stands for National Institute of Standards and Technology. If you go to their website, put any component name, let's say for isopropyl alcohol, you put it, try to download properties, it will ask you to pay money for that. So that huge data bank is available here. Secondly, suppose there's a new component, new molecule, which is developed by yourself, by your own innovation, by your own R&D, which obviously may not be available in the library of Aspen Plus. In that case, you can use a ChemDraw to develop a structure for that component, or you may have some basic properties like molecular weight, boiling point, or vapor pressure. And with those minimum properties, Aspen Plus software could be able to predict rest of the properties like density, viscosity, and so on, right? So that is also available in the Aspen Plus. We call them as TDE engine, thermodynamic engine. That means the based on the thermodynamics and the correlations built in, it could be able to predict the rest of the properties for the components. Okay. Plus, of course, some other things, batch modeling. So we can able to do batch and continuous process together, crystallization unit operations, solid modeling like filtration, drying, right? Whatever solid unit operation you name it, you will find that, right? And plus, we can able to do the operations like adsorption, like molecular sieve adsorption, PSA, pressure sink adsorption, right? Chromatography, right? All this you can able to simulate inside this environment. And there is one other platform we provide, we call that Aspen Custom Modeler. Why we provide it? Suppose there is a non-standard unit operation like membrane separation, which is more like a proprietary unit, right? So if you may not have that unit available in the library, one can actually develop your own model using Aspen Custom Modeler. This is nothing but actually like a Fortran-like program, but you really don't have to write a program and use the mathematical techniques to solve it. But you can use your own equations, and the program will do rest of the things for you. Meaning it will solve the equations, it will develop, it will create an output for your model, and then you can bring it into that main process simulation software. All right. Then after that, if you want to do energy analysis, for example, you know pinch analysis, right? To find out the cold and hot curves and find out the energy pinch points, right? To optimize the energy, software will automatically do the pinch analysis across the heat exchangers in your simulation platform. Then it does the cost estimation, as I mentioned earlier. Then it does the equipment sizing. Then it does the equipment mechanical sizing, right? So everything is one platform. And this is the example from Aspen Plus software. Yeah, I talked about that. So it predicts the pure component properties. I mentioned more than 24,000 components, 27,000 now is available in the library. Then it does the batch modeling. So you in yesterday's sessions, right? I saw the topics. You heard about reactive distillation. You heard about reactors. You heard about crystallization, right? How do you simulate that very quickly in the simulation environment? So that is very quickly one can do into the Aspen Plus platform, right? It helps to reduce the cycle time. It helps to reduce the experimentation. Very quickly you can do scale ups and so many things. All right. You know the term API, right? Which is generally used in pharma processes, right? So in streamlining the pharma API processes, this is very helpful from developing a new molecule, because pharma companies keep coming with the new molecules, new drugs always, right? And for them, it's very proprietary molecules. So typically they do a molecule development at lab level, from lab to pilot and pilot to commercial, right? So while doing this scale up, right, this is very important to do a proper scale up, right? Scale up is not just about changing the equipment sizes. Scale up is about the kinetics. Scale up is about the reaction. Scale up is about the resizing the equipment, right? Scale up is about the defining the agitator type, the speed, velocity, right? So that's all about the thermodynamics and chemical engineering about the scale up. Yeah, so these are some software names, right? So I mentioned about the properties, right? You see the property curve available, right? This is TXY diagram, ethanol water system, very common component name, right? So one can very quickly get that TXY diagram. So you define the temperature, give the range of vapor liquid equilibrium, and one should be able to get this curves very quickly. Okay. So this is best in class property data bank, and Aspen has has been awarded for many R&D patents and R&D awards for the property data bank. Similarly, multi-purpose model. When I say multi-purpose, because any process or typically spec chem pharma may have a combination of batch as well as continuous, or it may be just continuous or just batch. But at the same time, it will have the solid unit operations like a drying, crystallization, filtration, right? And it could be an extraction, right? And so many things, bleaching, right? So how can I simulate everything in one environment? Because continuous process are typically steady state, right? That generally doesn't change with respect to time, whereas batch are dynamic, right? So the output in the batch distillation, right, the purity of the fractionates, right, they keep changing with respect to time, right? So it is hard to balance between steady state and dynamic, right, because those are completely different unit operations, right? So that's how these technologies help you to do the simultaneous batch as well as continuous process simulation in one platform, meaning it can run both steady state and dynamic together, right? So this is an example. As you see, this is a batch process. You see it changes with respect to time. This is a batch column, right? And there's a continuous example, or semi-batch as well. Sometimes it could be a semi-batch, right? And sometimes it could be the continuous process, but feedstock keep changing, or catalyst rate may keep changing, right? In that case, how do you look at the profile? If my feedstock changes, how is my my product quality changing? How is my temperature profile in the reactor changing, right? Or if I'm doing a solubility analysis, if I keep changing the solvent percentage, how is my solubility profile changing? So I should be able to get it very quickly, right, using the simulation platforms. Yeah. Now this is an example. You see batch and continuous process. And if you see the 3D graph here, right, it shows the profile of the reactors here, right? So you can decide what parameters you want to track it, whether it's a temperature, pressure, flow, whatever you want to track it. And another important thing is the solid unit operations, right? In chemical engineering, we have MO, right? Mechanical operations. I still remember we used to study the grinders, the mixers, sieve trays, and so many things, right? Conveyors, crystallizers, granulators, right? Scrubbers. This is very important, right? Because these are also very important unit operations. So Aspen is the only software you will find all these unit operations inside the platform. Okay. So you remember, I think some of you are still teaching this mechanical operation. So particle size distribution, right? Crystallization profile, drying profile, right? Solubility profile, sieve profile, right? So you can very quickly get, you see this is a centrifuge separation efficiency, right? So this is very important to simulate in solid. So these are some examples of how these are rigorously simulated into the simulation platform of Aspen Plus. Yeah, this is Aspen Custom Modeler. As I said, if you have any proprietary equipment, one can actually develop the equipment using your own equations, right? And of course, you can create your own symbol and put it into the library, right? So that becomes your proprietary unit operation. No more you have to use like MATLAB or Fortran to code your own unit operation or simulate, right? This is available even out of box inside the program. Yeah, batch process developer. This is something interesting. As you see the pictures at the bottom, when we develop a new component, right? Typically in pharma or spec chem, right? Like a perfume industry, solvent industry, pharma ingredients, APIs, right? They are actually developed at a lab scale because one has to ensure the quality and a lot of approvals and all the things has to check and confirm, right? Lab scale. Once that is done, then that is done at a pilot scale. And so, for example, 100 ml to like a 5 liter to 10 liter to maximum 100 liter, right? And from there to 1 kL to 5 kL or 20 kL at a full scale, right? So while doing this scale up, what is important is not about just to change the capacity of the equipment, but important is to look at the kinetics, the reaction, the what you call the profile of the operation, then thermodynamics, right? And what it is called from a scaling up from lab to pilot to full, it is called the recipe management, right? So typically we develop a recipe, right? Like like in lab, we have a recipe, add 5 ml of this, 10 ml of this, stir it for 10 minutes, heat it up to 80 degrees Celsius and things like that, right? And then you separate it, filter it and crystal it. So this is a typical recipe in chemical engineering. Right? So that exactly you do in batch process development. From when you develop a molecule, so software automatically does it for you. You define component A, B, C, reaction kinetics, all the properties are inbuilt, and then define the equipments. And from there, click the batch process developer. It will develop the entire process flow diagram for you from lab to pilot, pilot to commercial. with the sizing of the equipment, with the batch cycle time, with the equipment capacities, with the agitator speed or whatnot, whatever is required for that, including energy requirement, including capex requirement, opex requirement, and so on. Yeah, we see some examples, right, from chemical pharma companies, right? You name any company, you will find the software, right? So typically those, I mean, all of these companies have benefited the report, right? Reduce the capital cost, increase the capacity, cut down the campaign preparation time, right? Help to meet the tight timeline for scale up of the plant and so on. Yeah, and finally, I want to summarize my first section of the presentation. Why Aspen Plus is preferred over other simulators, right? What are the key things? What is the important, right? And these are the key and unique things, right? Is about the properties. Very important. I keep repeating that because that is very, very important in any process simulation. Unless you have an accurate properties of any component, no matter how good you are into the calculations or no matter how good are into the process flow sheeting, right? So for example, going back to simple example, Q equal to mCp delta T equal to UA delta T. That CP, accurate value of CP is very important, right? That's why I think the properties are important. And we have this deeper and niche component data bank in the library, which is almost like 33,000 components now, right? We have a unique thermodynamic engine, which helps to actually develop the properties for unknown components, right? Aspen Plus can solve any large and complex problem, not just an equipment. It could be as big as like hundreds of columns and hundreds of pumps and heat exchangers or compressors, whatever unit operations you have, it can able to solve it, right? And of course, is a leader in distillation sizing, columns design. It can handle any type of complex distillation process, be it azeotropic distillation, it's a reactive distillation, any type of multi-phase distillations, multi-phase columns, multi-diameter columns, combination of batch and continuous, combination of tray and packing, right? In fact, it does have a proprietary tray and packing data bank. Meaning, for example, if there are packing trays from Sulzer, Coach, HTI, and so on, all that the proprietary data banks are available in the data bank here. That's why Aspen Plus is a preferred simulator in the industry over other simulators. Okay. Yeah, with that, actually, I'll take a pause here and I'll just, before I go into the case studies and real examples, I want to check if you have any questions from anyone. I'll go to the chat window and see if you have any questions. Anyone has any comment, question, feedback? You can raise the hand or you can put it in the chat window. Yeah. No audio, sir. Okay, so audio comment is a bit old one, that is for video. But any other comments, questions from anyone? No? Okay, if not, then I'll continue. Now, second section is important. Okay, you'll find more interesting. Okay, is there any comment? Yeah, so there's one comment. Does the software take care of time of the day? Yes, of course. So software take care of time of the day, time of the batch cycle time, time of the process. That's why it is very important to make sure that the software can simulate both batch and continuous together, right? So time is important, and one of the key parameter or KPI of the batch software is to optimize the batch cycle time. Okay. There's another question: can we simulate photocatalytic reactor in Aspen Plus? Yes, you can simulate, but not purely in Aspen Plus software. You'll have to use Aspen Custom Modeler for that. Okay, so in combination of Aspen Custom Modeler and Aspen Plus, one can simulate the catalytic reactor as well. Okay, there's another question from Dr. Umbriger. Software have intermediate data banks? Yes. So whether it's a pure product or intermediate or end product, all put together, madam, we have almost about 33,000 pure components, right? So depending upon what intermediate you are referring to, it may or may not have. So one really need to check in the data bank. But as I said, suppose A plus B gives C plus D, and there is a there is, let's say, B plus plus is an intermediate component, right? So we don't have to worry about that. Software will take care of generating its own properties for that intermediate components, right? What we need to define, what is A, what is B, what is C, and what is D, right? If I define that and you define the reaction kinetics, rest software will take care. Okay, so the intermediates will be automatically available. And suppose if the software doesn't have the intermediate, then you need to define the component name or structure with the 1 or 2 minimum properties like a molecular weight and boiling point. Then it will generate rest of the properties. Okay. There's one more question from Dr. Podolekar. Does the data bank contain ionic liquids? So you can simulate ionic components as well in the software, but then it requires thermodynamics to be selected accordingly, right? Of course, it's a good and valid question, madam, but of course there are certain limitations. So we need to use a third-party component data bank for that. I'm trying to remember the name of that. Anyway, if I remember, I'll put that in the chat window. But yes, there is a separate data bank we have to select for the ionic liquids. Okay. Okay. Good questions from everyone. Keep asking the questions. Meanwhile, I'll go back to the software presentation. Let's look at the use cases now. Okay. Okay, so you see the new term coming up there called performance engineering, right? So this is the new word from Aspen Technology for process engineering. So we call it as performance, right? Not really about process. It is about improving the performance of the process. Okay, and you see another buzzword there called plant digital twin. I'll come back to that digital twin little later, but let's understand the use cases first, right? So depending upon what role you are into. So one can be a process engineer, one can be a mechanical engineer, can be a cost estimation, can be a safety engineer, reliability, sustainability, operation engineer, as well as a planner and scheduler, right? Depending upon what role you are into, right? There are 4 key things which people do. One is a conceptual design, feed and economics, safety and operation optimization, right? Let's look at some of the examples, starting with conceptual engineering. What is conceptual engineering, right? So conceptual engineering is the development of a new molecule. How can I very quickly come to the market with a very quick development of molecule, very fast to the market, cheaper, greener, and of course, most importantly, cheaper, right? So that is all possible with this an integrated approach. As you can see, this is an Aspen at the center. So what you do is you actually develop a component, do a research, start with research, from there to pilot to commercial, and then from there you actually make it further detailed analysis for targeting the market, making sure that less capital intensive project, also of course safety and operability issues has to be resolved or minimized, and most importantly greener, cheaper, and earlier to the market, and that gives you the revenue, right? If I do not do that, if I just keep on doing the research and keep on developing the new molecule, but if I do not look at the market feasibility, if I do not look at the safety aspects, right, then you won't get any return. No one will invest that, right? So in same platform of Aspen Plus, one could able to do everything. Yeah, single environment for batch and continuous process. Yeah, this is an actual real picture from one of the example which I used, right? So be it a reaction, distillation, solvent extraction, crystallization, filtration, drying, right? One can simulate everything in the one environment. Yeah. So red fact for batch distillation, you can see the various curves, graphs inside the simulator. Okay. The other example to look at it in conceptual design, right? When I put a flow sheet together with my heat exchanger columns and so on, right? So once I do the sizing and once I get my heat and mass balance, what is important to look at for me is what is economics? How much is the capital cost? So one single click at the top ribbon button, you would get the cost of my process plant. If you change the location India, you will get the location for India. If you choose the location to Korea, you will get the cost for Korea. You change the location for Singapore, you will get the cost of that process plant for Singapore, including utility cost. Similarly, energy, right? Otherwise, you remember when we used to do project, we used to actually calculate heat and mass balance for entire project. Here, one single click, it will give you how much is the energy consumption for my plant, right? And how much I can save it. Now, heat exchangers, every plant will have number of heat exchangers. Are they operating in a safe zone? Is there any vibration issues? Is there any over design? Is there any mechanical risk inside the heat exchanger, right? Whether baffles are placed correctly, software will automatically check it. Safety, reliability, PSVV, blowdown, rupture desizing, everything it will look into it. Then if there are solid unit operations, that will look into it. Emissions, dynamic simulation, column operability issues, right? All is look at in a holistic view in one environment while doing the simulation, be it starting from a new product, from a profitability to energy efficiency, safety, and so on. Okay, so that's about concurrent engineering. And these are examples. Companies like ExxonMobil, Dowell Technology, Worley Parsons, and so on have been using this software for a number of years for optimizing the conceptual design. But just to elaborate a little more, right? These are some innovative things, and that's what I thought. It's very close to chemical engineering, and you would love it. Now, what we have inside the distillation column is the real geometries, real trays, right? So typically, distillation columns are designed using the non-equilibrium approach, meaning we do a lot of assumptions, right? For example, we assume that the trays are at equilibrium, the vapor living, liquid living are equilibrium, and that's what we play with the term called efficiency. Murphy tray efficiency, column efficiency, packing efficiency, HETP, because to factor those efficiencies, factor those unknown things, because we assume the equilibrium. But in reality, the columns are not in equilibrium. That is why Aspen softwares actually do the simulation using the non-equilibrium approach, meaning we don't have to define the efficiency, we have to define the actual geometries and flow profiles of the vapor liquid inside the column. And that's what you see. You'll actually see inside the column what is happening, whether it's a flooding, weeping. You don't see the number, but you actually visually see what is happening inside the column, right? Like you actually open a real distillation column and you are seeing in a plant. So virtually you are seeing in the simulation environment. That's what this is, the tray capabilities are available inside the simulation environment. Okay, this is very unique thing. Yeah, let's move to from conceptual engineering to feed. Feed stands for front-end engineering design, right? Here, typically in process industry, companies develop the feed package, which includes the your design data sheet, PFDs, line list, instrument, PNIDs, because that's also an important aspect, right? So within the simulation, with one single click, you can able to develop PFD, you can able to develop heat and mass balance, data sheet, equipment list, everything automatically. Otherwise, you remember, imagine how many draftsmen would be required to develop that. It's not a typically chemical engineering job to develop a drawing and punch in the data. Typically in the industry, draftsmen do that. But when the draftsmen do this job, right, it is more of a data filling job, because they don't know what value it is and how it comes from or how it is calculated. Chemical engineers know it better, right? So this is automatically developed from simulation. You see the PFD, heat and mass balance, data sheet, and so on. And this is called a feed package. And further, if you have to convert that into detail engineering from basic to detail, so these are non-Aspen Tech softwares like Hexagon, Aviva, and so on. But our softwares do integrate with the detail engineering softwares. So what are detail engineering softwares? Those are typically called 3D or the detail piping layout, piping engineering, stress analysis, and those things come into detail engineering. So we are not into detail engineering. Aspen is mainly into concept and feed and to operations. Okay. Yeah, these are some success stories. Yeah, so this is an example. When I'm into simulation, I can choose the equipment and just right click. If I right click, then select the type of equipment, you will get a data sheet within the simulation environment. And then one can save it, print it, PDF it, whatever way you want it. Next, economic evaluation. Here, once I develop the process flow sheet, I can quickly do the economic evaluation of my plant, right? Meaning I could be able to get the what you call the capex and opex, which is capital cost and operating cost, right? So here using the simulation and using the data bank, so software, you will be able to design the software, do the mechanical sizing. You remember, process simulation softwares are always a process design. They are not mechanical sizing, mechanical softwares, right? In order to get the mechanical sizing, you remember we learned equipment design. You need to calculate thickness, weight, baffle type, sizing, right? All that. So that is all about mechanical, right? In order to get the costing, we need mechanical information, right? So are we dependent on mechanical engineering? No. So what software does, based on the process design, before it goes into capital cost, it does the mechanical sizing and it gives you the capital cost of the entire process unit, right? So this is the one single model which gives the costing as well. Now again, you may have a question, does software have a cost database? The answer is yes. It does have a cost database of 89 countries in the world, and India also we do provide cost database for Mumbai and Delhi, and every year, twice in a year, we update that database into the software. That's what software also does, the economic analysis. You remember Pepe subject, right? At least I remember in my final year. So this is all about the economic evaluation. Yeah. And the integrated risk management. Now, this is important, and companies are very cautious about that. See, companies like Reliance, when I talk to their board of director, first thing they would ask me about the risk. If I'm going to put my money into this plant, like the $20 billion J3 Jamnagar project, what are the risk involved? So risk could be a political risk could be an environmental risk could be the market, the risk could be situations like COVID. These all become risk, right? And in that case, how is my project going to impact? So that is called a risk analysis, and risk analysis is done using various Monte Carlo analysis. So our software also does the Monte Carlo analysis, which takes care of these all aspects of the risk. Like for example, I'm giving a refinery example, Ratnagiri refinery. It is on hold now, and just because of political issue, there is no land available, right? Government has the money, fund is given by or shared by the Saudi Aramco, because it's a joint venture with Saudi Aramco, Indian Oil, and rest of the public sector companies. So money is not a concern, but there is a political risk in that. And because of just a political risk, it is on hold for last 2 years. Right? So this is also very important to look at the market risk as well. So that includes oil price fluctuations, the situations COVID, right? No one knew that COVID is going to come, and it has completely changed the market, right? Completely impacted. So that is called the risk analysis. And later, if you want, in the interest of time, I won't go details, but you can search in the Google what is Monte Carlo analysis. This is another aspect of being the process optimization. Okay. And finally, safety and sustainability. It's very important, right? And now again, the plant may be very good, your design might be good, your operations might be best optimized thing, but if it is not safety, no one is going to approve the plant. Safety is the prime most important thing in any process industry. Unless safety is there, there's no matter whatever you produce and how good you are, what quality it is, right? Safety is important. So that's what fire, the safety, emissions, all these are very important. And the most important thing in the industry to design the PSV, pressure relief valve, rupture disc, blow down walls, right? Because if there are any emergency situations, how I'm going to vent it, right? That's what you see, the flares are always burning in the industry, right? Of course, we see a lot more in India, but I visited many refineries in the world, many refineries in Australia, in Korea, and Japan. I mean, I still cannot believe those are called refineries. Very, not very, in fact, I would say zero emissions, zero flare. And that is what Indian government is putting pressure on the sustainability of the Indian refining companies. And that's what these softwares play an important role. And probably you might know, if there is no flare, or if there is a X percentage energy saving, these companies are given lot of concessions. They are given lot of funds. They are given lot of benefits from the government. They actually put in money if these companies save a lot of, they save a lot of emissions, they save the energy and so on. So safety is very important aspect. Now doing the PSV sizing, rupture disc, there are a lot of PSV codes, PSV sizing, API, TEMA, and all those codes are required. So those are actually used in the safety analysis. Okay. Safety is important aspect as well. And finally, of course, the safety documentation, which is like PSV walls and design capacities, operation capacities, right? Because typically there is always margin between design and operation, right? So that's an important aspect as well. Another important aspect is about sustainability, right? Now, what is sustainability? Sustainability is about emission, is about energy, is about carbon capture, is about CO2, right? That's all of it, is about the green green process industry, right? That's about sustainability. Now, when we talk about sustainability, there are two things. One is energy required in a process, which is called demand, and energy supplied, which is your utilities. For example, in any process industry, you will have boilers, you have HRSGs, you will have the turbines, right? You will have the waste heat recovery units, right? Those are energy supplied units. And who are the consumers for that? Consumers are your process unit. Every distillation column would require the energy, right? Every reactor, if it is heated, then you need an energy, right? So those are energy consumed. So one can optimize the energy consumption at a supply, at the demand side by optimizing the process. But at the same time, it is very important to optimize my supply of energy. For example, if I have a boiler, it can be operated on a coal, it can be operated on a oil, or it can be used certain amount of different type of fuel. So how I'm going to optimize my supply? Because if I save the money in supply, obviously at the same time, when I optimize my supply, at the same time, I cannot compromise on my demand. Let's say I need 20 tons of my HP steam per hour. So that is my constant demand coming, and one has to actually maintain that demand continuously, right? But while maintaining that demand, how can I optimize my production of steam? How can I optimize my flare there from my boiler units, right? So this is the balance between supply and demand, right? So we have to look at both the things, right? Not just one side, because mostly we are focused on demand. We know to optimize on demand, but at the same time, supplies are also important. So that is what we call simultaneous demand and supply optimization. Okay, so those are few examples I talked about, right? Okay, now other thing is very briefly, so when we do the planning in the refinery, right, how much would be my production planning, how much my planning for my gasoline production, my kero production, my aviation fuel production, that all depends on the demand from the market. But that is the demand, that is my plan. So I'm going to produce that these products for next 1 month. I'm going to run my refinery with Arab Light crude, with Bombay High crude, with my various crudes from various locations, right? So how the crude selection is done in the refining industry, it is depend upon what is the market demand and the crude availability and the crude price. But typically, what often happens in the plant, that I do the plan, but actual goes in a different way. So this is my plan, my actual production should go parallel with my plan, but it never happens because of a lot of uncertainties, a lot of factors, abnormality in the plant, process does not go as planned, or there's a unplanned event happen and things like that, right? So this is called the lost opportunity. So we are losing that much money. In order to bridge that gap, what really helps you is the simulation. So simulation actually helps you to bridge this gap. Simulation navigates you to come to the closer to the plan always. Okay, so of course this is a real example, but it takes a bit of time to explain. If anyone is interested, I can do that, because I myself work a lot and done a lot of consulting on this planning model update using simulation in refining industry, but that plays an important role in the refinery industry. Okay. Yeah, and finally, this is again a very innovative thing we call smart refinery, right? So again, refinery is not about distillation, it's not about cracker. The refinery is about cracking the crude into the molecule level. And this is something, the new trend coming up, meaning to get the properties of every component at a molecule level. You see, this is a chemistry, right? So we are bringing the crude, cracking it or separating in a column, and then cracking it at the various crackers to get the different components. You see here, you see LPG, you see motor gasoline, you see aviation fuel and diesel and so on. But whether I'm getting all the required properties here, right? Whether I'm complying with Euro 6 or Bharat 6 or Bharat 7, whatever is coming up next. What is my sulfur content? Because sulfur is the key thing in my properties. More the sulfur, cheaper is the crude, right? Higher is the sulfur, cheaper is the crude. Lower is the sulfur, crude price goes up naturally, right? So all these factors are important, and that's why molecular modeling is another new concept which is important in the industry. Okay. Yeah, and finally, operation optimization. Operation optimization is about the plant optimization. Once the plant is designed, it is up and running. The most important is how do I optimizing my plant, right, with my current conditions. And the other thing I talked about the training simulator, right? It is also very important. OTS, it is called it. So how do I train my operators? Because when process engineers join the industry, they cannot go straight away to control room and operate the plant, right? They need an experience. Although they are chemical engineers, they need experience for the operations of the plant. So OTS is nothing but a virtual plant. It is OTS actually creates a virtual plant into a computer platform, like using software like HYSYS, right? So that actually that is used to teach, to train the operators, process engineers. So they run it, they create a various scenarios, they trip the plant, they trip the power and see the impact, and then they take the various actions, and that way they learn it. So this is another aspect of the process simulation in the industry. So training is very important, training using the simulator. And it is there in other industries, like pilots are trained, right, in the flight simulator. Similarly, process engineers are trained using the process simulator. Yeah, so this is what we call OTS. Okay. Okay, now I'm going into the another topic. Okay, so I covered about the simulation basics, where Aspen stands in that. Then I covered about the industry use cases for conceptual design, operations, OTS, feed, economics, and everything. Now I will touch upon a new topic. Okay, I won't go details in the interest of time, but this is very, very important. Where is industry now looking into? This is about the sustainability. Sustainability is the very key word in the industry, right? People are talking about resource efficiencies. Resource meaning what are the resources like water, steam, air, hydrogen, nitrogen. These are called resources, right? Energy transition and decarbonization. How do I reduce my energy? How do I reduce my carbon footprint? And of course, the circular economy, which is about reducing the plastic use, recycling the plastic, right? Renewable feedstock. That's about the circular economy. So these are the three important things. And a lot of R&D, research, and the funding has been happening in this area. Okay. Let's look at some of the technology use case. I already talked about energy, so I skip it for a minute. Yeah, so this is about the energy consumption, right? So this is a typical column again, right? So how do I look at my column sustainability in terms of energy consumption, in terms of reducing emission, in terms of improve the margins, and visualizing inside the column what's happening for in my column for flooding, weeping, or any other operational constraints and so on. Okay, I want to give this BPCL example, Bharat Petroleum, where I myself personally engaged in this project, and we got an award from Government of India. Ascom India is a last year. So it's just a recent project, October, November we got it. It's the best innovation project awarded by Ascom, and of course there are a lot of other awards. But reason I want to highlight this because it is from government, and this award is actually given to Aspen Tech and BPCL. So we developed an emission model, what is called digital twin, for emission tracking, reporting, and controlling the emission. Whereas HYSYS model was developed to actually track the emission by controlling the CO2, SOx, NOx, and emission in the furnace, FCC furnace, as well as the rest of the process plant in the. This is for Kochi refinery, not for Mumbai. Okay, and the first principle HYSYS model was used for that. Okay, so this is a very unique and classic. This is a summary of that paper, but it has been presented in many international journals already. If you want, I can send a link or paper PDF copy. But this is a real case study where we have been awarded by government on this emission monitoring. So reason I want to share, because this is what industry is now looking into. Not about optimizing the column. It's about how do I reduce the emission? How do I reduce the carbon footprint? Many companies, including Reliance, you know what is Reliance chairman's the vision for Reliance? Not to put one more refinery or not to increase the crude capacity, but the vision is how Reliance can become by 2030 is net carbon zero. You see their the reports, the Reliance or companies like Reliance are targeting to become the net carbon zero by 2030, meaning another 10 years. They want to absolutely make the carbon emissions zero. So that is really focuses in the industry now. Okay, so that's about BPCL example. The second example about energy transition, right? Energy transition is about using the new fuels, new technologies, like hydrogen is now coming up as a new fuel, biofuels, right? Or fuel cells, batteries, right? All that falls under the under the energy transition and decarbonization, right? Now here you see the example. Sorry. Yeah, ERC, right? It's actually in a US research company. They actually recently use our software. You see, as I mentioned earlier, typically the distillation columns are used in a equilibrium approach, but Aspen has a capability to do the rate-based. Rate-based, you remember the term mass and heat transfer limited reaction kinetics, right? So that is being used in this distillation column design, wherein this company ERC in US, they develop a new what you call the solvent, which actually improves your CO2 capture, CO2 absorption, right? Of course, they may not mention the component name being a proprietary, but Aspen software is being used to develop that. Okay, so that is another classic example of how these leading research companies are being using to develop a new carbon capture processes. Okay. And lastly, about circular economy, it's very, very important. What is circular economy? It's about recycling plastic, it's about using renewable feedstock and so on. You can imagine the PET bottles, the drinking water bottles, which we use on our day-to-day life. If we go to a restaurant, we just simply buy the bottles now, right? We no more drink the normal water, even it's safe to drink, right? So, and that has created a significant plastic wastage, right? Almost like $1.5 billion of wastage of PET has been generated. So people used to make like dumping it into the sea, or dumping some of the concrete blocks and things like that, right? But now there's no more allowed, and it's not just in European countries or American companies. Even in India, plastic ban is there, and we cannot use carry bags anymore beyond certain micro size. This is all about the circular economy, right? Now we have engaged. So there are certain plants in India as well as in abroad, right? So one plant in Polygenta, which is in Nashik, they actually do this PET recycling. They collect the PET across all the municipalities from India, all the agencies from India who collect the waste, and they actually recycle to make it the pyrolysis. They use the pyrolysis process and they convert that plastic into the gas. This is an actual example which I'm showing here. So this is a pyrolysis of waste tires, but similarly they do pyrolysis of PET bottles as well, where the waste is actually fed into the process and the air and all that pyrolysis reaction happens, and they develop the pyrolysis gas out of that. And for that, Aspen Plus or Aspen polymer is being used. That, I mean, the bottom line here is the importance of the recycle, and this is what the new term called in the industry called circular economy. Okay. So people talking a lot about circular economy, and this, so industry evolve around these three things. Remember, you can note these things: resource efficiencies, energy transition, and decarbonization and circular. These will be the next key thing in the process industry. Not to, because the investment is saturating, the plants are saturated. You can see how many new plants are coming in India. No, I mean, there is not much investing happening. In fact, there is a lot of mergers happening. The plants are being shut down. People are not continuing to operate and things like that, because the sustenance become important rather than putting the new plant now. Right? So these are the key things here. All right. So I will take pause here before I move my next slot. Any more questions from anyone or any comment? One comment I see here: catalyst effectiveness study. I will answer this, it's coming soon. But yes, the catalyst effectiveness and catalyst deactivation is very well studied in both Aspen Plus and HYSYS, and we have a lot of examples, madam, where catalyst deactivation is being studied. Also, we can do cost analysis. Yes, only thing that the catalyst cost is not available in our library. In our library, only equipment, material cost is available, but not the feedstock, component, catalyst cost is not available. Because it's a huge market and a lot of components, it changes a lot. So we do not have that. That user has to input. But it's a good question. Yes, we do study catalyst effectiveness as well as catalyst deactivation profile. And of course, cost analysis, provided you input the cost data. Yeah, good question. Yeah, we have another 15 minutes. Any more questions? I have one more topic to cover about digitization, and most importantly, please stay until the end. My last section is very important. I'm going to talk about the future of this simulation and process industry. Okay, I see someone has raised the hand. Yeah, please go ahead. If you have any questions, you can unmute and ask, or you can put it in the chat window. Okay. If not, I'll continue. We'll keep some time for Q&A at the end as well. So I might extend little over time above beyond 3, but yeah, please stay until the end. Okay, now you see the title. Is the word changing? Is a question. But the answer is it's not changing. It is already changed. The word is already changed in process industry. You see the picture here at the background. You see everything is changing. Everything is become autonomous. Everything is becoming digital. And what we call it is new normal. For example, I myself has not gone to my office since March 2019. I have not seen my office building at all. But there's no impact on efficiency, no impact in my work, no impact in my what I'm doing day to day. That is what it is called word change. It is called a new normal of industry, right? So we call it is word is volatile, uncertain, complex, and ambiguity. And that is true. It in current situation, lot of uncertainty. COVID came in, no one knew. Very complex, volatile because of the impact, the government change, policies, price, economics, right? So how do I translate that into the process engineering language, right? Now that is translated with a new term called digitization. What is digitization? Digitization is the word which came in from Germany, where there was an industry revolution started with digitization 1, digitization 2.0, digitization 3.0. Now we are at the era of digitization 4. Now earlier that digitization was there in electronics and automobile industry, but suddenly people wake up and they actually investing a lot into the process industry digitization. So what is about digitization? It is about remote monitoring out of assets, meaning operating the plant remotely, plant insights remotely, meaning on my mobile device, I can able to see what is happening in the plant. I can able to see in my iPhone, I can able to see in my iPad, how is my distillation column performing? Is there any issue? Can I put an instruction from my mobile to the plant person directly and it takes automatic action directly? That is called remote operating asset. Resiliency, right, is very important. Safety operating conditions, optimizing the production yield, insights inside the plant insights, looking into remotely, right, as well as digitally, and most importantly, sustainability. Sustainability will keep coming, and you will hear a lot from me as well in this my presentation. So this is, so what is digital twin about? So I'll come to the definition of digital twin in a minute, right? But customers say focus on doubling the investment on digitization, right? So every company, I used to go with the companies, refining companies, I used to see the title process engineer, operation manager, process manager, maintenance manager, reliability, but I see digitization manager, I see chief digital officer. You heard the title CEO, CIO, but have you heard CDO, which is called chief digital officer? Every company will have that. Every company will have that. So that is what the focus coming on more on digitalization, right? So what is digital twin in today's world? It is about bringing artificial intelligence, data analytics into the process industry, because very important in the volatile market. It is about the doing complex trade-offs, sheer quantities, then changing the need for agility and so on. Okay. Here are the few words. So some definition. I purposefully put this, in fact, just to understand what does digital twin means. This is a new word, right? So digital twin is nothing but, there are various definitions I captured from multiple sources, and Aspen also defines in the same way. It is about virtual copy of the asset, process, business, meaning everything is on your desktop, at your home, at your machine, at your mobile device, at your tablet, right? Everything virtually you are operating, right? Provide a remote view of asset, right? What is happening in the plant, I can do that here. Predict the future result. I can actually predict, okay, my feedstock is changed, what is going to happen in my plant, how it is going to change my throughput, how it is going to impact my properties. Everything I predict sitting here, right? I don't have to physically go there. Then predict the asset degradation. I think madam asked just a question about catalyst degradation, catalyst deactivation, process failures, activities, and a lot of other things, right? So these are the definitions of digital twin, meaning creating a virtual asset on your machine, on your platform, and operate it remotely, right? These are some definitions of digital twin, right? In simple words, enabling remote work, monitor equipment remotely, check the health, and so on. Like a call center, right? Like I just call someone, and then like a bank, right? And they give you information about asset or about your health of your account. Is there any issue? Is there any wrong transaction happen? You can solve it remotely, right? So this is exactly we are going to do in the process industry, right? So let's look at the definition of digital twin, right? So digital twin is evolving profile of historical, current, and future behavior of the physical plant, right? So look at what's happening in the history, what is current and what is future of the plant in a virtual environment in my machine. That is called the word digital twin. And there are three types of digital twin. One is process digital twin, one is operation digital twin, and as well as the plant design twin. Plant digital twin is for design, operations is for running plant, and operation integrity is about the maintenance and equipment. Okay, so just an example. So you saw this diagram again. So this is a virtual digital twin for distillation column, right? So what I'm going to see here is I'll show you some examples. Actually, by the way, don't take this picture. This is a customer diagram I thought to share with you. This is an actual digital twin model for BPCL Mumbai refinery. Okay, this project we have implemented just last year, but remotely, sitting at their home in the office. This is not a control room. Okay, this is not a DCS room. This is actually they are running the plant sitting in their house. Okay, of course the graphics look like a DCS, but this is not a DCS graphic. They're actually trying to optimize their utility plant, right? So by clicking the buttons, of course, behind the scene, underneath this, there's a process model running, which is Aspen software. Okay, for end user, this is the platform. So what this does, it sees what's happening in the plant real time. If there is any issues, it quickly runs the model, and the output very quickly it sent back to the plant, and plant take the action accordingly, right? So of course, one may have a question, what's the role of process engineer? Of course, still process engineers are required. We are not eliminating any process engineer job here, but we are making easier for a process engineer to do their job, right? Otherwise, how this would have happened in real world, it would have happened like, then you have to go in the morning, first shift, then you take the logs and see the values, what has happened in the night shift, there is no proper data transfer, then you do the manual calculation, then by the time you do that, you lost the opportunity. And in this current environment, sometimes it is hard to go in the plant because of the travel restriction, COVID and all that thing. So these are some graphics. This is a real example. This is a real example of heat exchanger. This is my crude preheat train heat exchanger, in which actually in real-time environment, you see exchanger fouling, exchanger clean, and what is the delta. Okay, what is my heat duty, what is my heat transfer coefficient, what is my shell side temperature, and so on. It is a real-time environment. Real-time meaning actual real-time. Every seconds, every fraction of seconds is updated, not even minute. Any changes happening in the plant, and suppose this is 446 degrees C, suppose it becomes 480, so it is off, very off from the normal operating range, it will create an alert. So the process engineer, process manager, operator will get an SMS, email immediately, something went wrong in the plant, and it is not that they have to think and take the corrective action. Software will also suggest what action they should take. Immediately the alert goes, okay, this has gone off beyond the operating range, reduce this, change this. There could be physical inspection required. So it goes the message to the plant person to check that. That is what is really called a digital twin. And I'm not talking a dream. This is a reality. It is already there. Even India, it is in a BPCL Mumbai refinery. Okay. So this is another example. This is a C2 splitter column. Okay. I just put some screen capture just to give an idea what I mean by digital twin. This is a crude column monitoring, right? Crude column monitoring is not just a parameter, but you actually see. It is not with a CCTV camera you are able to see, but because it's a virtual plant, it actually replicating the real scenario in the process simulator. What is happening in the plant? Okay. Yeah, so that's about the process digital twin. What about operational digital twin? Operational digital twin is about supply chain, is about the planning, it about the scheduling, right? See, suppose my material is supposed to transfer from India to Europe or Europe to some other location, and if there is any disturbance, if there is an issue about the delay in supply or some abnormal things happen, right? So in it, how do I smoothen that? How do I reduce that supply time? How do I optimize the demand supply? So all that is done through the operational digital twin. Okay. Again, there are various examples, but I know time is a constraint. We're already at 3 o'clock. I need another 10-15 minutes or so. I'll skip this part. I'll anyway share the presentation to you, but I'll spend some time on this digital twin. This is important. This is equipment digital twin. Now this is very interesting. You see, this is my compressor, okay, and my plant is running, continuous plant, running and running and running. It never stops unless you push the stop button, right? But at one point suddenly it fails, breakdown happens, and you have to stop everything. Imagine how much it will impact on your cost. If one equipment fails, everything you have to stop, and that impacts your revenue, impacts your production, right? That's why I said earlier, you remember, I repeat that. No matter how good you are a chemical engineer, no matter how good you are a process engineer to optimize the plant, no matter how good is your output, the important is the plant should up and running without any failure. Despite of doing lot of maintenance, the plant fails, and that impacts a lot. That's why Aspen enters into this area, which is called the predictive maintenance of the equipment. So using Aspen software and using AI, which is artificial intelligence and machine learning algorithms, our softwares is able to predict the failure in advance. How advanced? Not just 1 hour or 2 hours. It gives an advanced notification. Okay, this compressor C101 is going to fail 20 days, 30 days, 40 days. Advanced notification will be given that this is going to fail, this is going to trip because of this reason. Imagine the technology power. And that 40 days advance is good enough for you to fix the issue. And the software is not going to just tell you equipment is going to fail. Software is going to tell you, okay, this is going to fail because of the excessive bearing friction, because of the oil issue, then correct that action so that you can avoid the downtime. This is what bringing artificial intelligence and data into the simulation. So what it does, it actually takes into historical data, patterns, and based on the AI, artificial intelligence, it actually tells you what is going to happen for equipment. Is exactly similar what people are looking into health industry. If I have to give a real life health industry, one person can get a heart attack, and by the time he actually gets attacked, he don't know. He assumed that he's health, he's doing exercise, he's having healthy food, but at one sudden they get heart attack. But if I have an AI into healthcare, looking at my historical, my health issues, my patterns, my food habits, whatever, my drinking habits, then it can able to predict if you continue to be like this based on your sugar parameters or based on your whatever the blood reports, right? This is going to end at this stage that way. That is, people are looking into healthcare industry. This is exactly same concept here. If I had to give another analogy and simple example, we do a lot of shopping on online portals, be it Amazon or Flipkart and things like that. If I go to Amazon, if I search, okay, I want to buy, let's say, the Xiaomi phone, Redmi 8, something like that. I search it, I just look at the price and I don't buy it, leave it there. Have you noticed that it keep popping you the messages until you buy it? Okay, you search it, this is an offer, this is a 10% discount, 5% cashback and things like that. Why? Because it learns the pattern, this learns from your history that this person is looking into this. And if you search that twice or thrice, it keep on probing you until you buy it, or unless you decide actually, okay, not to go and you delete that profile from there. That is again artificial intelligence, right? So what it looks your pattern, it looks your history, it looks your the historical profile. So be it in a e-commerce, be it a healthcare, everything is same. What it's now really doing is bringing the artificial intelligence and data into the process industry. And this is very unique. I do have a video, but I don't want to run it. I'll share with you later. I'll send you the link on that, how it works in real example, but that's how it works actually. Okay. So that is what we call the equipment failure, early event detection, what we call it. If you know, okay, I'm going to get a heart attack in next 3 days, okay, what I'm going to do? Is I'm going to sit at the home? No, I'm going to see my doctor and take the advice and take the corrective action immediately. But when I can do that, when I know that well in advance. If I do not that, then it fails, right? Same in the process industry. If I know well in advance, my compressor is going to fail because of so many parameters, or because of my suction pressure, because of my bearing, then I'll fix that immediately. That is what we call bringing artificial intelligence and data into the simulation. Okay, let's move on a little bit. And I'm coming to my probably my last part, which is I'll talk about industrial AI and future, but I'll go there. So now what is really coming into this, right, is about the data, is about the devices, and about what is that, what I mentioned, industry 4.0 technology. So just having data is not enough, right? For example, I know my blood parameters, I know my sugar level, I know my all my health condition, but having that data, what I'm going to do that? I need to know, I need to do a doctor, I need to have a consultant there, right, to analyze that and predict or prescribe the right solution for that. That is what just having data is not enough. So you need AI there, you need a knowledge there, you need a consultant to fix that problem. That is what just data is not enough always, right? So what Amazon does, what it does, it looks at your historical purchase pattern, and then if there is a similar offer or similar discount or similar whatever that thing you want to purchase available, it keep on reminding you, right? Because just data is not enough. The Amazon also knows what you are trying to buy as well. Similar here as well, right? I'll skip this in the interest of time. This is all regarding Aspen. Now we call this term as industrial AI, because AI is there in all the industry, not just process industry. AI is already there in telecom. AI is always there in healthcare. AI is always there in automobile, aviation, everywhere it is there, right? But process industry, it is maybe new, but at least it is picked up in last couple of years. That's what Aspen call it as an industrial AI. Now this is an interesting slide if you can look at it. Okay, so we call it candy store, but you see some term NLP, Python, OpenCV, TensorFlow, right? Lemur, then principal component analysis, neutral network, design experiment. What is this about? These are all programs. These are all data science programs. Now we all are chemical engineers. Are we familiar with this? No. Are we experts in data? No. Are we learning that? Can we learn that? Yes, of course I can learn, but it takes time. But then how chemical engineers can leverage this? I want to use Python in my process and in my simulation. How can I leverage that? And here is an Aspen comes into picture again, right? So this candy of store of data scientists, we bring into simulation for chemical engineers with a click of a button. How? Let's see that. Yeah, or maybe, yeah. So this is what we call new generation of solutions. So let's look at an example. So you see right hand side is the white box. What is white box? Is your process simulation model, first principle model, which is a thermodynamic model, right? Which is a chemical engineering, which is we are doing today. And you see left hand side, which is a black box, which is a data science language. And data science people only talk about Python, data, equations, algorithms, which no one can understand. And even if they present it, it is a black box because there's no output from that. As I said earlier, just having data is not enough. One needs to analyze it. One needs to produce the result. One needs to convert that into meaningful output. So, and the right hand side is the first principle model. Now, what Aspen is doing is combining these two into one box, which is called a hybrid model. So our next generation simulator, which is already released in last November, is called a hybrid modeling capability. And we call that as a gray box, where the data scientist, the AI ML is combined in the first principle simulation algorithm. And that is what is called a hybrid model, which is already available. This is already launched. This is already available. People, I mean, the universities who have the Aspen software, just upgrade to version V12. You can use it today because this is already available. So do I need to become a data scientist? No, this is for a chemical engineers because Aspen has already taken care bringing AI and machine learning into simulation, right? So one example I can do that. What AI, you can see, go to version 12, and if I'm developing a simulation flow sheet, let's say Aspen Plus, what it will do, if I put a column, it automatically suggests you, right? Like a Google, it will probe you, okay, add components. If you add the components, automatically it suggests you to choose the thermodynamic properties. Automatically suggests you to put the next equipment. So that is called AI. Okay, that's already built in. And I can show some, one or two use cases here, right? So as I said, I talked about a hybrid model is nothing but bringing the first principle model together with machine learning, right? So machine learning requires a good data, as well as not just data, but the extrapolation of data is very important, right? Not just data. Data is also should be a good quality, right? So if I combine that, then one can actually interpolate and extrapolate my properties accurately. I can analyze the my process very easily, run the model faster, and so on. And this is a big breakthrough innovation we have already launched in version V12. Okay, and you may have a question. Today I'm using simulation for first principle model. Then what is the use of my my hybrid model? Let me share some use cases here. Okay. Maybe a simple example. Yeah, this is the simple. Let's assume a crystallizer or reactor. Okay, so what I'm doing here is I can capture my, this is actually industry reactor, industry crystallizer. I can capture my thermodynamics. I know my kinetics. I know my heat and mass transfer, my crystallization nucleation rate, and so on. But what I do not know in this reactor is my contaminants, is my catalyst deactivation, is my side reactions, unknown side reaction, non-ideal mixing. If there is an agglomeration or sorting happening in the reactor, these phenomena are not captured in the first principle models. You agree with me, right, or not? So because this is how the simulation can do, but then the right hand side the simulation cannot do. But I want to know that's how, what's happening inside my reactor. So this I can actually capture that by capturing the data from the plant. So I bring in the data for every batch, every second the data has been captured. I bring that into my first principle model, and with this digital model, I should be able to capture all the phenomena, not first principle properties, but also the phenomena like my side reactions, non-ideal mixing, things like sorting, agglomeration, and so on. Okay. And the another example, you see, there's something called soft sensors, right? For example, I think there was a question earlier on catalyst, right? So this catalyst deactivation profile, or if there's an exchanger, right? Whether my exchanger is fouling, or certain properties which we may not be able to calculate using equations like color, morphology, corrosion, right? Which is very difficult to calculate, right? One cannot really calculate these properties, but these are possible using this hybrid models. And in other words, these are called the soft sensor to calculate the properties. Okay, so this is what we call as a hybrid modeling. Yeah, so these are detailed slides. I'll skip on interest of time, but I want to go to the next. So this is my last topic now. Okay, so I know it's we passed. Any questions or any comments from the organization committee? Should I continue another 10 minutes? This is my last section.
Yes, sir. Okay, no problem.
Okay, okay. I hope this is interesting, right? Okay. All right. So let me continue. So what I talked hybrid modeling is available today now. Okay. Now let's talk about the future. What is the next generation coming now? What is the future of process industry, or what is the future even for Aspen Tech, right? So delivering the future, right? Okay, let's look at what's happening in this technology in the industry, right? So people are looking few things. Compute power is how fast are your computers. Like we used to have mobile like 512 MB RAM and 1 GB RAM. Now we have 16 GB, 32 GB, 64, 128. Wow. I mean, capacity is increasing even mobile devices, right? Now, even for my PC, which I'm running, you can see that RAM, I already have 128 GB RAM. Even a very small laptop I have. So computer power, the speed is going up, right? And people are looking to extrapolate by even 10 raised to 16 by 2023. Edge devices, connected devices, right? So the investment will go from 1.2 billion to almost 30 billion. and the artificial intelligence pain. The investment you see in the year 2014, just $500 million. Now it will go almost to 40 billion. And then 85% of the top executives, CEOs of the companies believe AI will be the future for the companies. AI will be the future. Like Mukesh Ambani says, right? Oil is not the future, data is the future for Reliance, right? You heard that sentence from him, right? And he keeps telling that on his annual conferences. Similarly, the top executives say AI is the future in the process industry, right? So with this is a survey actually. I don't know, I can read, there is a survey from IDC report or something there, but this is a general market survey. But I do have another report, right? This is from the Intelligent Refinery report. This is from Accenture actually, Accenture Consulting Company. So what they found is which digital technologies are having the most positive impact in refining, right? So this is all about maintenance and reliability, production planning and production execution, all with the AI. That is what this report shows. Okay, now what is the next journey in the digitization, right? What we are looking for. So in 1970s, right, in 80s, people used to do spreadsheet calculations, okay, which is in-house tools or Excel calculations or manual calculations. Then simulation came into picture around 1980s. Those are individual people or process engineers used to do that. Then cross-functional people. I showed some examples of doing heat exchanger sizing, costing, environmental emission. That's all available today, and even the hybrid models are available today. But what is next? Next is the self-optimization. That is what is coming in future, which is bringing AI, domain intelligence to drive the plant automatically. The word automatic is very important, right? And that's the vision for Aspen Tech. Okay, of course, these are confidential slides. I'm not supposed to really frankly share, but yes, this is what we are working on. So we will be there in the market, what's called self-optimizing plant. What is self-optimizing plant? I'll give a very simple example. You heard about driverless car. Of course, the only company which is there is Tesla, right? Google driven cars. And I myself actually sat in the car in Houston and my colleague was driving. I was very scared first time. Very fantastically, of course, the roads and other things are there different, right? But anyway, the example of driverless cars, what it is, once you set the destination, the car will automatically navigate you to your destination. No matter how is the road condition, no matter what that traffic conditions are there or the signals and traffic, it automatically finds everything automatically. The first time when you sit it, you will scare, right? In Tesla car, one of my colleagues have it. So, but then very fantastic. I mean, it doesn't make a mistake. I mean, you can imagine. So those are called self-driven cars. Can we bring that into the process industry? One day our CEO thought and say, oh guys, okay, this is what is there. How can I bring that in the process industry? And that's how it triggered, okay, let's make it self-optimizing plant, meaning the self-driven plants, people-less, engineer-less plant. Obviously, it doesn't mean that we are eliminating any engineer or any operators. Those will be still required, but as much as possible, can we automate the things to make the plant safer, greener, longer? And that is our vision, to make the plant self-optimizing. Okay, this is vision, as you can see in the slide at right-hand corner. The word vision is there because this is not available today, but we are heading towards that. So first thing in the self-optimizing plant is the self-learning. The plant himself should learn based on the technology, based on their historical pattern. So suppose if the equipment failed in the plant and if the situation is similar situations is occurred, plant should able to learn automatically. Okay, this has happened in the past. It should be able to take a corrective action automatically in order to avoid the failure. Self-adopting, adopt the process, adopt the technology. Okay, and self-sustaining, meaning sustain the plant. I talk a lot about sustaining, right? So these are set of technologies and processes work together to predict the future and prescribe or automate the actions. Meaning, I as a process engineer don't have to go to the plant and look, oh, okay, my distillation output is not good. Okay, it is taking a lot of energy. No, before I actually see the plant should automatically learn it, take the corrective action, and should be able to run the plant smoothly. That is what is called automate the actions. And that is what is a vision. It's called self-optimizing characteristics. So there are 3 characteristics we are looking for: self-learning, self-adapting, and self-sustaining. Yeah, so self-learning is utilize the data from across the environment to get the smarter and increase accuracy of the scope of the production. Take the data, improve over time, right? Learn from the pattern, learn from the history. Again, the Amazon example, right? Or healthcare example I gave. If I have a data, if I know my buying pattern, okay, in Diwali I buy the clothes, okay, in Christmas I buy this, okay, this is my historical pattern of buying my last 3 years. Automatically starting January 2021, my Amazon should be able to automatically probe up with this information. Okay, this is January, last 2 years this guy has bought this one. Okay, coming March, okay, this is some other festival, buy this. So this is what exactly I'm talking about, self-learning. Right, same like cars, right? I'm giving an example, car. Self-learning, if there's a traffic signal, whatever, the map will automatically navigate you, reduce the speed, increase the speed, change that lane, everything will happen automatically. That's about self-learning. Then self-adapting, react, change the conditions. That is called self-adapting. If I know there is a traffic and the car automatically changes my direction or lane or reduces the speed, exactly same thing should happen in the plant. If I know that, okay, my plant is not performing as it was expected, if there is a drastic change, if the column is flooding, change the process condition, change my feed, change my steam flow rate, whatever is required to do that. That is called the self-adapting, right? And finally, it's about the self-sustaining. It's not just about the running the plant. Am I able to run my plant in a sustained way? Is it my plant running in a lower emissions, lower energy, as well as the lower carbon emissions and so on, and prevent any performance degradation? And how do I sustain longer? As I said at the beginning, like people used to talk 20 years, 25 years as a life of a plant. Now people are talking 60 years, 70 years. All the new plants investments are coming up talking for longer life. That is called self-sustaining, right? So in summary, this enterprise value chain is self-optimizing, balancing supply, demand across multiple plants for maximizing the result, right? That is what we call smart enterprise, smart devices, smart mobiles, right? So we all are smart people these days, right? Everything is smart. You don't see any mobiles with a keyboard any days, right? When we started using Nokia phone, those days are gone. Even it's hard to find a keyboard mobile. So it's a smart things, right? Smart devices. Same thing here. It's a smart plant, right? So what's happening now? What I do next with this is continuously deliver insights to improve the operations by automatically read this. I'll take a minute to read this, right? Continuously deliver the insights in the process operations to improve it, to automatically setting through the noise to provide transparency and guidance on what matters most. Execute autonomously. This word autonomously is very important. Request human approval if required and recommend human intervention if required. Meaning the plant should automatically run, but if it get confused himself, it happens, right? In the life, we ourselves get confused a lot of times, right? And we take advice, we ask others. Similarly, if at all it is required, ask human approval or recommend human intervention based on the risk level. If it is too much of risk and the plant himself cannot take the decision, of course, process engineer has to step in and correct it. But if not, if it's a normal continuous process, it should run automatically. And that's what we call smart enterprise. And this is a picture of a smart enterprise. This is a 3D graphic. Okay, so if I set my target, you see green one is autonomous, yellow one is approved, and red one is intervention. Meaning whatever you see in the green operations, green color, they will run automatically. The yellow ones, okay, you are not confident that okay, they will run automatically, then put an intervention for approval of human there, right? So process engineer has to step in and take the decision. And red in by default has to be operated by the human, right? Similarly, in the driverless cars, okay, it can be run at a certain length, but after that, if you want, okay, after that late signal, you don't believe that, okay, then you do the manual intervention. That is what the future of this process industry. Yeah, so we call it the self-optimizing plant to run the plant in autonomous way, be it design, operations, production, reliability, maintenance, in everything actually. Yeah, and this is the key step to the journey of smart enterprise. Okay, and of course I did not talk much, but needless to say, all the platforms are not I mean there are no more required to install in physical machines or any hardwares and everything. This is all about IIoT and cloud. Okay, everything is managed by cloud. Yeah. So asset optimization, which powers the smart enterprise, right? So we talked about asset optimization at the beginning, but at the end, what we are doing, it should power and with the smart enterprise, and that is the vision. That is the next generation. When I say next, means we do not really have to wait decades, right? At least I do not want to wait for my retirement. I want to see this happening in a couple of years, right? And what is final? I end with Aspen Tech mission statement: accelerate the digital transformation in the process industry, which we serve, meaning which could be any industry, whether it's an upstream, midstream, chemical, pharma, metal, mining, power, whatever. We want to make sure the plant will be autonomous, but at the same time, there is no compromise on safety, safer, greener, longer, and the faster. Because time to market is very important, right? We want a quick return. Longer is important. Life, greener, like a health and safety. That's all. Thank you, everyone. I hope it was useful to give an overall perspective of what is today, what is happening, and what will come in future. With the right examples, I tried to share my best. Okay, so I know it's we pass almost an hour, and we passed the hour, but it's 20 minutes extra. But I still, if you are interested, I'm okay to take any questions you have. Any questions you have, please feel free to ask me. You can unmute yourself and ask the questions. I will share the deck by tomorrow. I will email the PDF copy to Patil sir, and then he will share. But please feel free to ask any questions if you have. There's some question. Okay, let me read it. How much time lag will be there in the values in comparison with the real values? Okay, so there's a question from Professor Karthik, I think. How much time lag will be there in values in comparison with real values? No lag. It is actually real time. Real time, meaning a fraction of second. If I have a live, then I can compare with the simulation. There's a question from Mr. Ravi Shankar. Will it predict the scaling and compare? Of course, software does predict the scaling. I said falling, right? And the same phenomenon, it does predict the scaling and compare with the efficiencies. Yes. Any other questions? Catalyst effectiveness, I talked about. All process industries really challenging. Yes, and that's true. Process industries are always complex, right? Any other questions? You can unmute now. I think it's fine if you want to talk here. Can AI predict tie lines for extraction? I don't think you need AI for that. Even today, in Aspen, we have a software called Aspen Batch, which is used for extraction processes. There you can get tie lines. That is even today possible using basic simulator. Of course, AI would certainly help there, but even today, it's a question from Mr. Sayed. So it can predict using Aspen Batch today. This is for batch extraction. Any tips for us how we can prepare our students for getting job in software-based company? Oh, this is a tough question for me. I do get a lot of resumes. Yes, of course, this is a dream for everyone to get into software industry. But I want to clarify, don't call it as a software-based company. Okay, let's call it a process-driven company, because I myself never call I'm in IT. I'm still a chemical engineer, and you can imagine based on my language, which I talked about, right? Aspen Tech like companies still are a domain company, and the development and everything happens actually in our headquarters only. But yes, to get into our industry, what is required, sir, is basically a domain expertise. We hire people from the process industry. We hire people from refinery. We hire people who have experience in the chemical companies. And then software learning is not a big thing. Anyone can learn it very quick. Learning Aspen Plus is like 1 week job, according to me. right? But we need a people who know how to run, not how to run the software, but how to predict the results. That is very important. And we encourage your students to contact me if there are any opportunities. um, I recently hired a person from PVPIT actually. He is a fresh graduate. He was working in Lakshmi Organics, and he approaches. We found you can. I mean, what we interviewed is about his chemical engineering knowledge, not about the software. Can you contact more details? Of course, yes. My contact details are shared earlier, but I'll type in here as well. You can contact. Please feel to reach me anytime. Any questions, I'll be happy to share. Can we please share your email ID? Okay, let me type. Yeah, this is my email ID. Yeah, one thing I would advise, since most of the people are from academy here, there was a link I shared earlier. I'll share that offline as well. If you go to our Aspen Tech website, you will find at the top menu there is a university program. If you drop down that, there's a downloadable link for teaching programs for teachers for using both Aspen Plus and HiSys. And there are modules which you can use that as a laboratory exercise for the students, right? So at least if you have a process modeling and simulation subject, you can use that as a laboratory exercise, right? There are 10 to 15 examples available for each of the software. Can we use it municipal solid waste to energy? Yes, any process industry, be it a municipal solid waste, be it a coal gasification, whatever. I think anything you can simulate here. It has to be a process. What we do not do is we do not do any mechanical things. Any process where is a conversion, where is a reaction, there is a kinetics, we all do that actually. Okay, any other questions? I have time until 4, so no restriction. So I have blocked until 4 o'clock. So I advise few things. Go to our website. Of course, that videos I could not run. I think there is an audio issue, but those are also available on our website. And please feel to listen those videos for your information and knowledge, right? And since you are from academic, if you really want to, if you have a Aspen software, you want to use it for your students. I think most of this universities have the colleges or universities have Aspen software, so you can use those examples to teach the students. Okay? Most important thing I would encourage you guys or most of the professors here to take an industrial project where you can do the process simulation, right? You charge it, and probably you can make some money and or jointly sponsor with university or whatever, right? Like most of the universities do. So that way you take a project, solve the industry problem, and then probably that would help to generate the revenue as well. Okay. So I talk a lot of things, but important, if I have to summarize something, process simulation is fundamental. For that, of course, chemical engineering is key, not the software knowledge. As I said, I came from Shivaji University, PVPIT only, right? I mean, of course, we learned Fortran, C++, but that is not useful for me at all. Today, I'm here just because of my chemical engineering knowledge, not because of the software. Okay. Okay, if no questions, then should we conclude or?
Okay. Good. Thank you, sir.
Thank you. Yeah.
Now I request Professor Unmesh Patil, sir, to deliver a vote of thanks.
Okay, thank you.
Good afternoon, everyone. It's great. Thanks for this last session of 5 days FDP. So, eminent speaker, Mr. Sunil Patil from the Aspen Technology. We are very fortunate to listen him for I think more than 2.5 hours, and really very much thankful for him. For initially he introduced the Aspen technology, then discussed about the data bank for the products of petrochemicals, pharmaceutical industries provided by the Aspen Technology, property analysis tools of Aspen Tech's batch and continuous process simulations, then solid process optimization using Aspen Tech, thermodynamic expert systems, that is TDE. Then he discussed the case studies on performance engineering, conceptual engineering, feed and economics, evaluation of feed and economics, safety and sustainability, operations optimization, concept, equipment digital twin, industrial artificial intelligence, and lastly, very interesting thing, that is the self-optimizing plant. So really a bundle of knowledge he has thrown towards us. Depending upon capacity, we have to digest it. Sir, we are very much thankful for you. I know you are very busy person. So thanks for taking out time, sparing with us and giving the latest idea what is happening in industry and what is the future of chemical industries. I am proud to say that Sunil Patil sir is a proud alumni of our institute, and because of our request only, he has spared time with us. Very much thankful for you from the our institute and all the participants attending this session. Thank you very much, sir.
Thank you, sir. Thank you, and appreciate everyone for listening this almost 2.5 hours. Thank you for taking your time. Thank you all.
Thank you, sir.
Thank you.
Here we conclude today's second session, and I request all the participants, please be online. We'll take 5 minute break and immediately we'll start to valedictory function. So please be online.